Oi, Shivtesh, am I audible? Am I audible? Am I audible?
Yes, yes, you are audible.
Okay, sir. Okay. Uh, Good morning to one and all present here, respected dignitaries and all keen participants. I, Master Bhavya Shah, welcome you to the international event conducted jointly by the Textile Association of India, Inchalkaranji Miraj Unit, and DKT's Textile and Engineering Institute. As Hardy is incomplete without laurel, textile is incomplete without oil and lubricants. Before we head towards the event, I would like to introduce you to our honorable panel of judges. Our first judge of the panel is Judge अबे next कर. Our first judge of the panel is Dr. Pradeep Kapadia sir. He is currently working with the Total Energy as a team leader in research and development. He has a work experience of 1 year and the company with the company and an industrial experience of 10 years. Our second judge of the panel is Professor P.S. Joshi Shah. He holds an MTech degree in textile technology. He has 4 years of industrial experience and 30 plus years of teaching experience. Before the event starts, here are some short guidelines for you. Participants have to turn on their cameras during the whole presentation and Q&A session, and the presentation max duration is 8 minutes and 2 minutes for Q&A session. Okay, so I would like to invite our first participant, PPT 2207. I would like to please present your screen. 22007, please start your presentation.
Can you see my screen now? Am I
Audible as
on?
well as screen is visible.
Yes, it's audible. You can start.
Actually, we can't turn on the camera while presenting the screen.
Okay, so we'll do one thing. We'll present your presentation. You can turn on your camera. Is it all right?
Ah, no, we will present.
Okay, you want to present. Okay, then start. No issue. You can
Yeah,
start.
okay.
Good morning, everyone. Myself is one sec. Good morning, everyone. Myself is Niveta, and my teammate is Ari Vijayshri. We are coming from Sona College of Technology, and we are here to present on the topic oils and lubricants, conservation and sustainability. Let's see about oils and lubricants in textile industry. Oils and lubricants used to reduce the friction, heat, and wear between the mechanical components that are in contact with each other. Lubricating oil is used in motorized vehicles where it is known especially as motor oil and transmission fluid. And we will see the difference between the oil and lubricants. Oil can also be used to the lubricants mechanical systems, but contrary grease and lubricants, you pour oil into the system, after which it is automatically lubricated. If there is any important to regularly check the oil in the system and a change or replenish is necessary. Next, the lubricating agent in textile industry for finishing. In lower liquor ratios and high temperature, when fabric is processed, is full loaded rope dyeing machines. It is a crease or crimp, and it is a wrinkle line. In high temperature, it creases or cave mark wrinkle lines is formed. These are permanently seen on the fabric surface, so it cannot be removed easily. So the lubricating agent is used to prevent tuning crease and etc. So the vegetable oil is used, such as sunflower oil and linseed can be used. Linseed oil can be used. Buyer or consumer does not accept the crease mark in product, so using the lubricating agent is a proper solution of the mentioned problem. Next slide. Lubricants are classified into four types. The four different types are oil, grease, penetrating lubricants, and dry lubricants. Few examples of lubricants are fatty alcohols, esters, etc. And we have collected few samples here. The first sample I'm going to show is this oil. This is used in knitting machines. This is single. You can use this oil for single needle overlock, etc. And the next oil I'm going to show is synthetic oil. This can be used for the synthetic purposes. And the third one, this oil is used for the machine oil. The three samples we have collected. Next, we are going to see the composition of lubricants. Lubricants contain 90% of base oil and less than 10% of additives. Vegetable oils are synthetic liquids such as hydrogenated and polyolefins. Lubricants and oils is a fundamental design element of textile machines. The first process is the spinning machines. It is excellent in corrosion protection, and in knitting machines it is a long lasting service, and in weaving machines it's a longer intervals between the maintenance operations and the minimum quantity lubricants. Next, the fourth one is the finishing machines. It is a resistance to water, steam, and fifth one is stencil frames. It is less residued due to high separating effect. Next slide. Next is oil and lubricants conservation and sustainability. There are different types of methods. The first conversion is waste plastic into the lubricating base oil, and the second conversion is waste plastic to oils for tribiological applications. And the third one is water repellents from vegetable oil. Fourth one is recycling of used engine oil by different solvent by adding different solvent. And fifth one is sustainable alternatives to the lubricants. Sixth one is usage of gear oil to achieve the sustainability. And the last one is development of green process for a polyalpha olefin based lubricants. Next will be followed by Vijay Sri.
Okay, let us see all the method in detail. So first process is conversion of the waste plastic to lubricating base oil. A new process has been developed for the conversion of the waste plastic to lubricating base oil. So it has also been demonstrated that waste plastic and the Fischer tropset, which is a kind of a wax, can be co-processed to produce a base oil. So this process uses a thermal non-catalytic atmospheric pressure pyrolysis. Pyrolysis is nothing but it's a thermal decomposition of the oil at a certain temperature. Process that converts the high molecular weight molecules to a lower molecular weight molecules in the lube range oil. Hydroisomerization is a process. It's also nothing but it's an isomerization of the alkane hydrocarbons, which is used to convert this product to low pour point oils of the unconventional base oil quality. So I'll explain the method in a very simple way. First, the raw materials we are taking, that is a plastic. So the feedstocks are tested whether it has the polyethylene. So the polyethylene content should be 96%, and the polyethylene terephthalate should be 4%, and the pyrolysis process takes place, in the hydroisomerization process takes place, and the viscosity is find it. So there should be a pour points between minus 13 to minus 37 degrees Celsius, and the viscosity index in the range of 150 to 160. And next is the conversion of the waste plastic to oils for the tribiological application. So tribiological is nothing but the study of the interfacing surfaces, which is used to reduce the friction, which produces heat, etc. So there are different techniques available for the transformation of the waste plastic into oil. So some of the methods are thermochemical treatment or thermal cracking, hydrocracking or hydrogenation, and the catalytic degradation or the catalytic processes. So what are all the applications? What we can do from these oils? So this oil can be directly used in the machines to reduce the friction. They can be used in the knitting machines, rigger and bench machines to increase the productivity. And next is water repellents from the vegetable oil. So water repellent finishing is an important process in the textile industry as well as the other finishing processes. Coating on the fabric can be used to achieve the substantial water repellent effect. So besides the fabric treated with the polymeric coatings with impart a stiffening appearance, which is undesirable. In this study, the water repellents have been prepared from the various vegetable oils with different amounts of saturations in the fatty acids. So this vegetable oil is actually treated with a fluorinated compound. The cotton fabrics were treated with the modified fatty esters also, which is obtained from the rice bran oil comparative to those obtained from the sunflower oil and palm oil. The water repellent ability, yellowing, and the softness of the fabric are after treated were evaluated as a function of the amount of the water repellent used in finishing. The results showed that the palm oil ester derivative imparted higher water repellency than the other oil. Next
You
is
guys are left
recycling.
with the last 1.5 minutes.
Yeah, okay, fine. We'll stop there. So recycling of the used oil by the different solvent. Actually, the oil which should be reused with dissolving retinol. The first method is to filter all the impurities, and then it is treated with the 100 ml of butanol and 100 ml of methanol. So by this way, we can obtain the result. Yeah. And the next is sustainable alternatives to lubricants. So other than the petroleum oil, with the range of natural synthetic base oils can also be available. So when formulated from the advanced biomass materials, lubricants can even become more environmentally friendly and being biodegradable, low toxicity, and less likely to bioaccumulate. Next is usage of the gear oil. With the goal of making a significant contribution to sustainability, Kluber Lubrication developed a synthetic gear oil with the properties matched to textiles mission requirements. So this advantages are the less waste, increased productivity, etc. Next is sustainability of the non-edible vegetable oil based biolubricant for the automotive applications. So non-edible vegetable oil is formed, which is completely non-toxic and zero ground greenhouse emission. So they are very good for the good anti-wear property. They show anti-wear property. They have high viscose index. They have low evaporation rate, etc.
Hello, I'm sorry to cut you in the middle, but your time is up. I would like the judges to start the Q&A session.
At least we can conclude.
Okay, do it in 30 seconds. Fast.
Yeah, sustainability and the conservation of materials can be implemented easily in textile industry. Oils and lubricants being an essential oil in the industry, it can also cause the damage to the environment. Sustainable development encourages us to conserve and enhance our resource base by gradually changing the ways in which we develop and use technologies. So thank you for the opportunity given. Thank you one and all.
Nimita, this was a good attempt of nice presentation.
Thank you, sir.
Thank you, sir.
I have got one question.
Yeah, sure.
What property of oil is important if it is to be used for knitting needles and that cylinder part?
Actually, it should have the stain. It should not stain the fabric, sir. It should not have any color. It should be lightweight.
Light, right?
Yes, sir.
So,
Should not stain. It should not cause any damage to the fabrics.
okay. Now, Pradeep sir, do you listen me?
Yes, I can hear you.
I hand over the charge.
Sure. First of all, thanks for a wonderful presentation. I've got two questions.
Yes,
So
sir.
one that you mentioned about recycling plastics for base oils.
Yes, sir.
That's a really good concept. But you
Yes,
said
sir.
it has to be, the feedstock has to be specific. So for future, how do you see this technology being used if very specific feedstock only can be used? That's number one. And number
Okay,
two,
sir.
once you said conversion ratios are something between 50 and 70%. So what happens to remaining 30%?
So actually, for the first question, sir, like all the plastic contains polyethylene. So most of the plastics can be reused, to convert the base oil, sir. Most of the plastics we can recycle, and it's a very good way to protect our environment. And can you repeat the second question, sir?
Conversion rate is between 50 and 70% for most of the plastics. So what happens to rest of the plastics? Like
No, sir. Actually, we didn't say like that. I actually mentioned one of the properties of the recycled oil, sir. I didn't say the conversion process is among the ratios, sir. It's between the ratio.
okay, sure. Thank you.
Yeah.
Thank you so much.
Thank you so much, sir. Thank you.
Okay, so let's head on to our second participant, PPT2214. You can start presenting.
Yes, sir, I'm ready, sir. Once again.
Okay.
Sir, Pradeep sir, in sequence it is number 3.
Sure. Thank you.
Is it presenting, sir?
Yes, your screen is visible.
If you want to, like, we can present from our side also, if you want.
Okay, sir. Will you please present, sir? We will explain, sir.
Yeah, sure. But let me know when to change.
Okay, sir.
Okay, sir. Pleasant morning to everyone. I'm Harsha Prada and my teammates is Dhanushree. We are from the College of Banariman Institute of Technology, Satyamangalam. And our topic is innovation in softening finishes for fabrics and garments. Next slide, please. Next, sir. And the main contents of this topics are special finishes for synthetic fibers, types of fabric finishes, garment finishes, functional finishes, feather, feather touches and ultra soft touch, rubbery touch, non-stick Teflon spray, stone wash, nanotechnology and nano coatings in textile finishing, low or ultra rolling finishing. Next slide, sir. Introductions. What is finishing? Finishing is a process convert the woven or knitted cloth into an usable fabric or any material and more specially to any of the process performed after dyeing the yarn or fabric to improve the law. Performance or coat, hand coat, fields of the finished textiles or clothing. Some finishing techniques such as bleaching and dyeing are applied to the yarn before it is woven, while others are applied to the grey cloth directly after it is woven or knitted. Next slide, sir. Types of fabric finishes. There are many types of fabric finishes. Some of them are sanding, washing, massaging, coating, glazing, burnout, antibacterial. Next, sir. In fabric finishes, there are three main types of finishes is there. Temporary finish, semi-durable finish, permanent washing, bleaching, dyeing and coating. After that we see about special finishes for synthetic fibers. Finishes have been developed to improve the fabrics in many ways such as enhance appearance, color, pattern, sheen, change texture, embossing, brushing, smoothing, improve feel, softer, crisper, firmer. Different types of finishes for synthetic fibers. There are four types: heat settings, anti-pilling finish, anti-static finish, non-slip finishes. Next, sir. Heat setting. What is meant by heat settings? The main aim of the heat setting process is ensure that fabric do not alter their dimension during use. Fabric can heat set using an iron or medium or high heat for 3 to 5 minutes. Polyester, in which the fabric is subjected to the actions of high temperature. Temperature range fibers minimum temperature, maximum temperature, time in seconds. Polyesters 170, 210, 15 or 50. Polyamide 6.6, 170, 210, 50 or 40 amide. PA 160, 180, 15 or 40. 160, 180, 15 or 40 acrylic, 160, 180, 200, 15 or 14 elastomers. Next slide, sir. Anti-pilling machines. Anti-pilling finishes, sorry. Synthetic fibers are more ready brought to the surfaces of a fabric due to their smooth surfaces and circular cross sections and due to their higher tensile strength and abrasion resistance. Nitpicking also occurs by abrasions. Individual fibers work themselves out of yarn loops onto the surface. And the garment will cut a point on rough metal. Knitting is susceptible to these effects due to the open view and bulky. Next slide, sir.
Okay, sir. I'm going to start anti-static finish. Anti-static effective chemical or highly inert chemicals and require thermosol or heat treatment for fixing on polyester fabric. Eliminates dust from clinging to the fabric. Polyether agents are likely useful, but it should not affect the dye equilibrium on fiber, lest they impair the rubbing fastness. Next slide, sir. Non-slip finishes. Give the filaments a rougher texture on fabric surface. Silica get dispersions or silicic acid colloidal solution are used in combination with latex polymer or acrylate dispersion to get more permanent effect. Along with stimulators, improvement in resistance to pilling or sagging. These polymers finishes are also contributes in imparting a softer and smoother handle to synthetic fabric without making it water repellent. Next slide, sir. Next, sir. Government finishes. Government finishes consist of a series of finishing operations performed in the government to improve its aesthetics, handles, and functional properties. A series of finishes operations. Government industry finishing is a process which contain of pressuring or ironing, folding and packing of garments. It's important to increase attractiveness and or serviceability of the fabric. Finished garments are folded and packed in the individual poly bags. Later, packed garments are placed into cotton boxes. The important functions are trimming, stain removing, repairing, pressuring. Next screen, sir. Garment finishing agent, dispersing agent, lubricating agent, pH regulator, anti-back staining, anti-cross staining, cationic dye
You guys
fixing.
have 1 minute left. You should jump to the conclusion now.
May I continue, sir?
No, you can like just conclude, go to the conclusion side and conclude it within 1 minute. You just have 1 minute left.
Okay, sir. Conclusion. Okay, sir. Move to the screen to conclusion, sir. Before, okay, sir. Pass down effects. Garment washing is a novel processing to import worn out look, to modify the appearance and to improve the comfortability of the garments. Bleach wash is used to fade the color or demean in a higher degree, as well as bleach wash has effect on the physical and mechanical properties of the denim. The sole purpose of garment waste is to remove dirt, dust, rust, stain, oil, etc. Thank you, sir. Thank you for all.
It was a good presentation, informative also. I would like to know what is the action of anti-static finish. Will you please explain? Dhanashri? Okay, Harshiprada.
Yes, sir. Sir, its action of adistatic finish is an highly inert chemical, sir. It eliminates dust from cleaning to the fabric, sir.
Which chemical is used for that?
Sir, I don't know, sir.
Okay. Pradeep sir, you may ask.
Thank you. Again, it was a really good, very informative presentation.
Thank you, sir.
Just have a quick question. For example, if I have a towel or a napkin, and if I want the most important properties are, first, it should be able to absorb the water, and secondly,
Yes, sir.
it should feel soft to the hand. And sometimes you have these towels that are very hard. So how do
Yes,
you
sir.
balance? Because for softness, you need something which is hydrophobic, and for water absorbing, you need something which is hydrophilic. So how do you maintain the balance between that? Do you know what type of materials are used and how balances are imparted?
Sir, I think anti-skid material, sir.
Okay, okay, sure. Thank you.
Thank you, sir.
Okay, I would like to call next participant, PPT 2216. You can start presenting. 16.
Please present screen, sir.
Should be present from our side or you are going to present?
You present. Thank you, sir. May I start, sir?
Yes, please start.
I'm myself Travis Sanjay Nande, and my teammate name is
Myself, Shmila Vinod Patil.
We are from DKT Textile Engineering Institute, Uttarakhand, studying in a second year fashion technology student. Our PPT topic is industrial lubricants used in the textile industry, fundamentals and significance. Next slide, please, sir.
Content in this presentation are presenting in the 3 points. First is the lubricants used in the textile. Second one is the fundamentals used in the textile. Third one is the significance used in the textile. Now these 3 points are presented in the details. Next slide.
Next slide.
Introduction. Primary purpose of the lubrication to the reduce wear and heat between the connecting surface in the relative motion. Next slide.
Sir, again next.
Click.
Lubricants for textile machine. While working a textile machine, lubricants are used for better performance and better high productivity. Lubricants used for textile machines like as a grease, oil and fluid. Now we can see in detail at what textile machine, at what purpose lubricants are used. One by Shulila, please go ahead.
Click the first one is the motor bearing grease. During the operation, motors are frequently switched on and off. So, because of high variation and high temperature operation of the bearing base, so keep the uniform consistently in the grease. Grease is the absorb the lubrication motor bearing work well. It gives long-term lubrication in the became technology are withstand the high temperature and provides consistent lubrication. Next, just click. Just click on. One second. Second one is the high-speed comber. The synthetic oil are used for the comber gear box. The provides high strength film for contact surface and does not rupture under the high loads. Next one.
Our third part is the drop frame top roll end bushes. In this, grease is applied in between the bearings in the top roll and end bushes. In that, if a grease fails to perform its function, then it impacts on the hardness of mounted rubber present on the roller because of temperature rising. It affects on the evenness and the quality of slimer. For the better performance and better quality, we have to use lubricant. I found one lubricant which has a Beacon represented by Beacon's lubrication technology, that is a Beacon grease. This controls temperature of bearing. Next, sir. Next one is ring frame Aurora bearing. lubricants provide smooth structure and offer least internal resistance to the smooth rotation of these precising bearings. In this ring frame, rear and front, both bearings are required to rotate in the same speed. Here the lubricants is used because to reduce the variation in the speed of bearing, because variation causes damage on the quality of yarn. So the lubricants is used here to add bearing to avoid internal resistance between the bearing. Next, sir. Knitting oil. Knitting oil ensures the high lubricity and low frictional coefficients between frictional partner and needles. In Wickham's lubrication technology, the star oil KNT range of knitting oils have a lower volatile loss, thereby ensuring a lower oil consumption per machine per day. So it reduces the friction and unnecessary rise temperature, and it ensures longer life to needle and sinker. Next slide, please. Fundamentals. Quality of textile and output depends on the efficiency of precise working of multitude moving parts, moving bearings, slides, elements, complex gear mechanism. These mechanical parts are exposed to some forces and demanding conditions. In order to provide effective lubrication for the textile machinery, lubricants are need to absorb high speed variation, control temperature, and lubricants is mainly to used to keep moving parts apart. So please next slide.
Our next significant first point is the reduction friction. Lubricant reduce the friction between the contacting surface. Main role of the lubricants is to keep away the moving parts, so it is reduced to friction, then the result it does not affected on the product. Next one is the transfer heat. Lubricants function to reduce the friction resistance and thereby improve efficiency. It generates less heat. Main purpose of lubricant to absorb the heat variation and transfer heat.
Third one is prevent corrosion. Lubrication helps to prevent corrosion when machinery parts works. It comes in contact, and corrosive part create a resistance to process. So avoid this problem. This lubrication is used and it prevents the corrosion. Next slide, sir. Thank you. Thank you for all, sir.
Thank you.
Pranali and Shivlila, your presentation was good. It was oriented to particular applications from textiles. Okay.
Thank you, sir.
And now I have got one or two questions. Somewhere at the time of motor gearing, you said that heat is also to be dissipated. Now, how heat is taken care by the grease? You said that grease is used and that lubricates the bearing. Also, heating is prevented. How heating is controlled by grease?
Because provides the grease.
Okay. I have one more question. You said that function of lubricant is to keep the surfaces apart. Using lubricant, we try to keep the surfaces apart. Friction is reduced. Is it possible to keep the surfaces apart in each and every component?
No, sir. Particular.
Okay, go ahead.
but it makes to make
Okay, okay,
film between surfaces.
okay. Pradeep sir, your questions.
Thank you. Again, a good, wonderful presentation. I have a question on knitting oils or needle oils. Here, whether we want or not, there will be some amount of oil inadvertently in contact with the
Repeat.
fabric which is formed. So this oil needs to be washable. So how do you
Sir,
impart
repeat the
washability?
question.
Sure. So my question is
Sir,
regarding
repeat
knitting
the
oil.
question.
Yeah, yeah. So my question is regarding knitting oil.
Huh.
So whether we want or not, inadvertently, some amount of oil accidentally splashes on the fabric, right? So this oil needs to be washable. So how do you impart washability to the oil?
Sir, no idea, sir.
Okay, no issues. Thank you.
Thank you, sir. Thank you, sir.
Thank you so much. Okay, now let's head to the next participant, PPT 2204. You can start your presentation.
Yeah, okay, sir. Is my screen visible?
Your camera is on, you are visible. Should
Yeah.
we present or you are going to present?
Yeah, I'm going to present it.
Okay, start.
Yeah. Just
Okay. Good morning to one and all present. I am Deepa Dashni and my teammate is Shankanidhi. We are from Banariamman Institute of Technology and from the Department of Textile Technology. We are going to present on the topic Innovations in Softening Finishes for Fabric and Garments. Let's start with the introduction. In textile manufacturing, finishing refers to the process that converts the woven or knitted cloth into usable material. It is done to improve the feel and performance of the clothing. Textile finishing is the term for chemical and mechanical process used on textiles after they have been made. Let's move to the next slide. They are basically classified into two types of finishing, which is chemical and mechanical, and there are various types under them. These have many advantages over the finishing, but they hold a bit of disadvantages also. Today, we have taken many other innovations which we are going to present. Over to my teammate.
Yeah, the innovations of garment finishing through garment wet processing will add values to the garment and the additional effects become the clear differentiator. Garment finishing can be used for various applications like t-shirt or trousers, but majority of effects are more popular in casual wears and denim segments. So when we comes to innovations, when we make the fabric so flexible and we come to reuse, recycle, and regen, where regen asking polyester is the cooling and it's very free to get dried out. And we get for regen Kotna polyester, it is natural touch fiber which is gives a comfortable feel to wear it. Then we go for regen aqua cool polyester, it is sweat absorbing and quick drying fabric which helps the people to get rid of any skin disease and other things. Then we have other six innovations and let's see this. And next comes the Aquatex finish. The traditional finishing process for fabric requires the addition of chemicals. These chemicals decrease the lifespan of the fabrics. So Aquatex system only uses the regular water at ambient temperature to attain adequacy of such fabrics in the trade and also make them more profitable and make the lifespan increase. So we'll go for next thing. It is feather touch and ultra soft touch, and it will be held by the partner.
Okay. Feather Touch and Ultra Soft Touch finishes are commercial names produced by heating with successive treatments. These play a vital role in wrinkle-free finishes by imparting better tear strength. Unless other chemicals, these do not leave a yellowish substance on the fabric. They impart excellent softness with bounciness in garment finishing. Let's move to the next slide.
Yeah, we come to rubber touch. The rubber latex provide a lustrous, brittle handle with characteristic rubbery effect, which are hand wearing. In leather finishes, it is applied as a final finish treatment, which are after enzymes or stone wash or after mechanical abrasion and enzyme treatments, where this rubber touch is used in jackets and the gloves, where it gives a shiny appearance to make it so polishable. So next, we'll next topic. A non-stick Teflon spray.
This is a very new method, non-stick Teflon spray. This is mostly used in fabric that is used in industries where many dust particles will come settle in the fabric. This lubricant forms a non-stick coating which does not permit the dust to settle on the fabric surface. This makes the product ideal for cement plants, textile mills, and industries where constant flow of dust and contaminants affects the conventional lubricants. This is a new generation multi-use lubricant based on polytetrafluoroethylene. Let's move to the next slide.
Yeah, the next slide is ozone fading in denim. So when we come for denim, the indigo dye stuff tends to fade or turn yellow due to the presence of sunlight. Where nowadays all people use denim as a main dress to just get dressed up. So we use it day by day. So we when we come to zone ozone fading in denim, the deteriorating effect has on denim apparel is practically irreversible. So it is so hard to get turn yellow and it never gets faded again. Yeah, next go to next topic. Cellulose wash.
Usually the denims are washed against rocks to get the faded look, but the clothes will turn old as we are washing it. Now, cellulose enzymes have gained acceptance in the garment wash industry as means to achieve a wash down appearance without the use of stones or reduced quantities of stones. This will give garments the wash appearance and soft hand. These enzymes are different from alpha amylase used for starch removal. These will give a garment a washed appearance and soft hand. This has the advantage of not turning the garment old, but it will give the faded look that the denim is needed. Thank you.
Friends, again, it was a good presentation, particularly targeted to some applications. Good presentation.
Thank you, sir.
I have got two questions. Rubber touch finish. If it is applied to the garments, will it reduce the comfort?
No, sir. So it is done to make the garment look shiny and polished.
Agreed. That shine we get, but
Yes, sir.
will it change the comfort? Because when
No, sir. Yeah, I get you. So when we get the rubber touch finish, no, it's not going to get into the fabric. So it's going to be a top of it. So the leather gets polished and the fabric never gets damaged.
Acha. A second question is related with Teflon finish.
Yes, sir.
Whether applied Teflon finish is going to come in contact with human body.
No, sir. It is also applied on the outer of the fabric, which only avoids the settle of dust on the fabric.
Otherwise, this Teflon is very harmful to human health. Are you aware of that?
Yes, sir.
Yes, sir.
What is the effect of Teflon as far as always we are using non-stick cookwares? What is the effect on human body, human health?
So it may cause any skin diseases to what the people's wearing.
Okay. Okay. Kapadia sir, please.
Thank you, Professor Joshi. So again, it was a wonderful presentation. It
Thank you, sir.
covered various specialty finishes. So my question is in line with what Professor Joshi was asking about Teflon, because many fluorinated compounds are harm to environment, especially marine life. So apart from fluorinated material, have you, when you are going through literature, have you come across any non-fluorinated material or compounds that will give you same finish without the issues associated with fluorinated materials?
So what we use here is a spray, which is is used to only remove the dust from the fabric, sir. And none other than this.
Rubber touch also gives the same property, so we can even use rubber touch instead of spray.
Sure. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Okay, the next participant is PPT 2218. You can start your presentation.
Can you share PPT slide?
Yeah, sure.
Good afternoon, everyone. Myself, Sweta Shitalkul.
And myself, Sakshi Sangramani.
We are second year fashion technology students from DKTE Textile and Engineering Institute, Isalkaranji. First of all, thank you to giving us opportunity to present our presentation on the topic lubricants used in textile industry, fundamental and its significance. Next slide, please.
I would like to give you a short overview of the presentation. In this presentation, we will talk about the basic information of the lubricants. Then next one is the need of the lubricants. It means for the proper functioning of any machines with moving parts and to keep machines in a good condition, the lubrication is important. Then the types of the lubricants and the importance of the lubricants in different textile machines. And the last one is the significance. Please next slide.
As we know that the lubricant is a substance usually used to make to reduce the friction between two mutual surfaces and to make the slides smooth slides smoothly pass to each other. Therefore, it covers, and as we know that the lubricants it covers the every stage of manufacturing process. It means that from the spinning of the cotton into the yarn through all the last textile production. Next, Sakshi.
Now the basic needs. Just imagine there is no lubricants. Then what happens? Because of the metallic contact, production of the machines are reduced. There is a friction, there is a variation in the speed, and due to the speed variation, this speed variation is also effects on the quality of the production. Because of the metallic plus rollers, friction is produced and the corrosion occurs, and hence the life of the machinery is reduced. Less quantity and the quality in the production directly affects on the profiles of the industry. As mentioned above 5 points, uh, now we get now we get that how lubricants are important in industrial machines. Next slide.
Types of lubricants. There are the basic four types of lubricants. First one is the oil, second one is the dry lubricant, and next is the penetrating lubricants, and last one is the grease. These are four are the basic types of the lubricants in textile industry. The two types, that means the oil and grease. Two types of lubricants are basically used. Then in next slides we are going to see how these lubricants are used in different textile machineries. Next slide, please.
In spinning machines, the gear speed. In spinning process, speed frame is used to insert the small amount of the twist to sliver and is wound on the bottom. In this process, gears are used when are working in the when they are working. Friction is produced to reduce the friction. And to protect from the corrosion, lubricants process is used. In auto corners, automatic cones are inserted by using at the bottom of the circular disc.
Yes. In drawing system, in frame machine, drawing process is covered. Then in this drawing system, there is a series of slivers are passed through the roller series in which the sliver gets the parallelization, and therefore there are the rollers. It means there is a friction. To reduce these frictions and keep machine uniform speed, we have to use the lubricants, and therefore there is a lubricants are used to reduce the friction and also to reduce the corrosion. Next slide, please.
Next, please.
Also, whenever there is a metal surfaces in contact with each other, it reduces the friction, and in variation in speed, it directly affects the production of the industry, and therefore we have to maintain the speed of the machine, and we have to use the lubricants. Sakshi, go ahead.
Next slide, please. In knitting, knitting machine components subject to high stress, high load, variation and the varying operating conditions. Factors such as the extreme temperature variation will violated roles in the stitch forming elements. These lubricants are to protect the stitching form like the needle's carriage guide and also ensure the good sourceability of the oil during fabric processing. It increases the performance and the reliability. Next slide, please.
Importance of lubricant in weaving machine. In weaving machine, fabric is formed in which there are the shuttles, ribs, etc. Therefore, there is a corrosion. It happens, and also in weaving machine, the lubricants provides the longer service lives to the machinery, and their lubricants are used in the weaving machine. Next slide, please. Importance of lubricants in finishing machines. In finishing machines, grease resistant to the water and steam, and it is used at the steamers, rolling, bearing, and rollers. And to resist that, we have to use the grease and lubricants. Next slide, please.
Now the significance of the lubricants. As we seen in the previous slides, there are some basic significance which are it helps to reduce the friction between two surfaces. It resists oxidation and it also resists the rust formation. It must be act as a good cooling agent and for better quality and quantity of products, lubricant is essential. Next slide, please.
Next slide.
Thank you.
Thank you.
Shweta and Sakshi, your presentation was also nice. It was again particular application oriented presentation.
Thank you, sir.
Okay. I have got few questions, maybe one or two. Many times you said that corrosion is protected by use of lubricants. How corrosion of the system, how corrosion of the machine part occurs?
Sorry for disturbance, sir. Please start your cameras.
Okay.
May I repeat the question?
Yes, sir.
Okay. How corrosion of that machine part occurs?
The many times there is a friction between the two metallic surfaces, and due to the humidity and temperature, etc., the other different
effects on the these are the effects on the machine parts.
Now, what is the application of dry lubricant in textile machines? Can you give some example? Solid lubricant or dry lubricant?
Sir, we have no idea. Sorry, sir, we have no idea.
Okay, Shweta, can you answer this? Dry lubricant used in textile machine.
No, sir.
Okay, no problem. Don't worry. Your presentation was good. Pradeep sir, please.
Thank you, Shweta and Sakshi, for your good presentation. Just have a quick question. You mentioned different type of lubricant. So, fundamentally, what would be the difference between grease and lubricating oil? And how do you define their application? Like in this particular machine, whether a grease to be used or oil to be used, how do you define that?
Grease is not oily, and oil lubricant is a it is like a flow, like its property like flow.
Right, right. So their application will be based on the physical properties, right? What is the more fundamental physical property, like whether it's fluidy or not fluidy, that will define the application? What happens if you put grease or oil on any surface, especially something which is not horizontal?
A liquid is a fluid means and but grease is a, not it is sticky or it's not fluid means it has more surface tension. It is a solid like
Yes. Okay. Good. Thank you.
thank you sir.
Now let's ahead to the next participant, PPT 2226.
This is a request for each and every candidate. You have to start your camera while presenting.
Santosh, please share the slides. Am I audible to all of you? Hello.
Yes,
So,
you are audible.
thank you so much. Thank you so much, sir. So, first of all, now I'm starting my presentation. First of all, good afternoon, everyone present here. My name is Janamjay Narvaria, and my partner name is Santosh Chaudhary. Today, we are giving our presentation on a topic innovation in softening finishes for fabric and garment. So, Santosh, please next slide. First, I will give you about the brief introductions about the softness. Softness, what softness means, and what are the softness which are used for giving the softness feel. So first, I will tell you one example, giving the one example how you identify the naturally the softness, which fabric is more softer and which fabric is not the softer one. So whenever you go for buying a fabric, you feel the fabric by touching the two fingers, by touching them, keeping the fabric between the two fingers, and you identify that this fabric is very softer and this fabric is not softer. That is nothing but the definition of softness, the means by the textile ones. And if we go to the softness which imparts the impression of softness is nothing but the softening. So here, the softener's main purpose is to improve the static property of the textiles. It gives the various properties such as soft, full, super soft, smooth, elastic, firm, dry, and sludgy, etc. The second point is it also gives to the physical property nothing but elasticity, survivability, abrasion, resistance. Santosh, please next. After applying the softeners, what effect is given? What effect what my molecules in addition penetrate to the fibers and provide an internal plasticization of fiber forming polyester by reducing its TG. And it depends on the ionic nature of the softener molecules and the relative hydrophobicity and the fiber surface. And after effectiveness, we have to see also the characteristics of the softeners, and softeners are having the main characteristic hand imparted, and the property of softening agent depends on the physical state of the softener, its chemical nature, and the behavior of the fabric. Low viscosity liquid softener produce a flexible and silky handle. So here viscosity impacts the major roles. That is nothing but if we apply the low viscosity, the example is given to you, and we impart with the high viscosity nature, so it's having the less silky handle. So this is nothing but the characteristic softeners are sometimes implicated in the quality and the environmental problems. So while using the chemicals, we also have to see the biodegradableness of the chemical, and as well as the ecological to the environment, and as well as if we are talking about the textile material, we have also have to see the that it will not affect the human skin. Next, please, Santosh. Before talking about the new softening agents or softeners, in 90s, 1900s, the people are using the waters, soap, and olive oil and tallow oil for making the fabric soft. For example, if you are considering the cotton without after a treatment, if you feel the cotton, it will bit harsher. So applying this tallow oil and olive oil and some soap and water, the people using this in the ancient time for using the softeners. So for the first time, the innovative and advancement in the softeners are anionic softeners. In this, the anionic softeners orientate themselves with the negatively charged ends repelled away from the negatively charged fiber surface. And the second one is cationic softeners. So cationic softeners orient themselves with their positively charged and towards the partially negatively charged fibers. Non-ionic, this is the best softeners. By my opinion, the orientation of non-ionic softener depends on the nature of the fabric surface, with this hydrophilic portion attracts the hydrophilic surface and hydrophobic attracts towards the hydrophobicity. And during the research going on, me and Santosh, we identify that silicon is the mostly used softener in the industry nowadays. This is the non-anionic and the cationic example for silicon softeners are there, and they provide very high softness, special hand, and high lubricity, etc. Another one is the polyethylene. Polyethylene, these are the polyethylene modified by an air oxidants in the melt at high pressure to add the hydrophilic characteristics. And then another one is the amphoteric. The surfactants used, the surfactant containing the potential anionic and cationic group within the small molecule. Santosh, please next. Given briefly above slides, these are nothing but the figure that is stated that the first figure is cationic hydrophilic group, where the positively charged ion attracting towards the negatively surface of the fabric. And in the anionic, you can clearly see that the negative charged ion is repelling the anionic compound away from the fabric, and these are the non-anionic hydrophilic groups. Santosh, please next. Thus, after considering all the softeners, in the left hand side, you can see the various softeners, and in the upper columns, there are various properties are given. That is nothing but the softness, lubricity, hydrophilicity, substantivity, and stability to yellowness, and non-foaming. So, if you can see that due to the less time, I cannot explain the full side, but you can see here the silicons having the positive characteristics present. So that is why people are mostly using towards the silicons, giving the more to the fabric and the garments. So Santosh, next page, please. Now I will hand over the mic towards my colleague Santosh to present the another other slide. Santosh, please present.
Am I audible, Janamjay?
Yes.
Yeah. So silicon softeners are the most widely used softeners in the today's world. And so there are three types of classification in the silicon softeners that are non-reactive, reactive. Non-reactive softeners are based on polydimethyl siloxanes, which is PDMS, and they are non-durable. So it is used very less. Then reactive, PDMS polymer is modified with silane H or silanol functional group. So the durability of the softener increases very much. So reactive is also very much used. And third is organofunctional. Organofunctional reactive groups introduced in PDMS and like carboxyamine and epoxide to improve the orientation and the substantiality on the fiber.
Sorry to interrupt, but you have just 1 minute left. You can jump to conclusion.
Okay, sir. And so these are the silicon's fiber structure of chemical structure. And silicon softeners are very high softness, special unique hand, high lubricity, good sewability, elastic resilience, and these all properties are inherited by the silicon softeners. This is because the postulate that's to create the methyl group shields the oxygen atom from the outside contact. And polyethylene based softeners, these are also widely used in the today's industries, and they are extremely stable to the extreme pH conditions and the heat provided by the fabric, provided to the fabric. And finishes in garment form, it protects the permanent crease settings at desired place, and garment seam puckering is also minimized due to the softening effect. What are the effects of the softeners on the environment? PDMS ecologically inert, and no effect of aerobic or anaerobic bacteria is there, and also it do not inert biological process during wastewater treatment, and there is no also aquatic harm to the aquatic animals, and PDMS present is effluent in the form of tiny dispersed droplets, and if sludge is also formed, then when it is incinerated, silicons get converted to silica, water and co. As landfills introduce PDMS, soil naturally gets degraded. Thank you.
Okay, good.
Santosh and Mr. Janmeja, it was a good presentation.
Thank you, sir.
I have got two questions for you. What is internal plasticization, because of which we get better surface characteristics, better softening?
Sir, internal plasticization is depends upon the structure of a fiber or a fabric, and as well as the viscosity of the nature of the softener, sir. Sir, if we take the viscosity, less viscous material for the softeners having the more crystallinity, then it is having the most plasticization between them. But if we consider the hard viscosity and the more crystalline structure of a fabric or a fiber, you can consider, then it will make the fabric more stiffer, not softer, sir. So this there will be situation arises.
Mr. Santosh,
Yes, sir.
you said that silicon type finishes are giving very good properties, good
Yes, sir.
softness. What is exactly mechanism of that, because of which the fibers or fabric becomes such soft?
Sir, because silicon have the compounds, reactive groups and organo groups also in the silicon, and they form a layer on the fabric surface, which give them a lubricating finish and softness to the fabric. Yes, sir.
Acha, so action is limited to surface.
No, sir, and if the softener also imparts in the fiber also, due to that the plasticity is also formed, as you said earlier, sir.
Acha. Pradeep sir, please, your
Yes, sure.
questions, please.
Yeah, thank you. Thank you for a good presentation. Just have one question. So you said silicone softeners are widely used for softness, which is absolutely correct. So
Yes.
depending on the substrate being used, for example, it's cotton, polyester, or blend. How do you change the softener composition?
Sir, silicon is also present in cationic and non-anionic. For the cationic, the cellulose type of fabrics is used for the cationic cellulose silicon, and the non-anionic is used for the synthetic types of fabrics.
Okay, thank you.
Thank you, sir.
Thank you so much, sir.
Thank you, Shantosh and Janamjay. Okay, let's head to our next participant, PPT 2223. You can start your presentation. '23. Would you like to present or should we present the screen?
I will present.
Okay.
Good afternoon, everyone. My name is Ankita Mrudyuse. I am from Kabnur. Uh, is screen visible?
Yes, screen is visible. Load
Yes.
your presentation.
If you want, should be present from our end. Should be present from our end. Let us know.
Okay.
Good afternoon, everyone. My name is Ankita Mrudyuse. I am from Kabnur.
Good afternoon, everyone. My name is Rahil Prakash Ghore. I am from Ichalkaranji.
We have been doing fashion technology course for 1.5 years in DKT College of Engineering, Kolhapur district, Ichalkaranji. We would like to give a presentation about the oil and testing, oil and lubricant testing and their standards. Next. Oil and lubricants testing and their standards. Next. Objective. Definition of the oil, types of oil, transformer of the oil test, definition of the lubricant, compositions, types of lubricants, feature of lubricants, applications, key function of the lubricants, what are the lubricant standards, elements of the lubricant standards, and conclusion. Now further point will be explained in Rahil.
Next slide. First, we will know about a definition of oil. Any of numerous greasy, usually liquid substances from plant, animal, or mineral sources that do not dissolve in water and are used especially as lubricants, fuels, and food, petroleum, paint made of pigment, and oil. In simple language, we can say that oil is the lifeblood of an engine, and just like the blood in our body, it is required to fulfill different types of functions of engine or machinery. Next slide, please. There are two types of there are two types of oils: mineral oil and synthetic oil. Next slide. Mineral oil is any of various colorless, odorless, light mixture of higher alkanes from a mineral source, particularly a distillate of petroleum, as a distinct from usually edible vegetable oil. The name mineral oil by itself is imprecise, having been used for many specific oils over the past few countries. Most often, mineral oil is a liquid byproduct of refining crude oil to make gasoline and other petroleum products. This type of mineral oil is a transparent colorless oil composed mainly of alkanes and cycloalkanes related to petroleum jelly. Next slide. Second type is synthetic oils. Synthetic oil is a lubricant consisting of chemical compounds that are artificially made. Synthetic lubricants can be manufactured using chemically modified petroleum components rather than the whole crude oil, but can be synthesized from other materials. There are numerous benefits of synthetic oil: better low and high temperature viscosity performance at service temperature extremes, and better viscosity index, better chemical and shear stability. Next slide.
Transformer of the oil test. Transformer of the oil test is dielectric strength, moisture, acidity, extrafixal tension, Dielectric dispersion factors test for the coercing sulfur in oil, test for the oxidation stability, specific resistance, flash point, pour point, viscosities, slopes test, dissolved gas analysis. Next, for example of the test. Next. Dielectric test. Dielectric test, an increasing AC voltage of the rated frequency is applied to the electrons which are the immersed in the testing oil with the gap of 2.5 mm. Approximately at the rate of the 2 kilowatt per second, starting from the 0 up to value which produce the breakdown. The test kit will have a provision from the automatic switching off of the supplied voltage within 0.02 seconds. The test shall be repeated 6 times on the same cell filling, and the arithmetic mean of the result is noted as the electric strength or the VDV. Long form of the VDV is breakdown voltage of the oil under the test. The test shall be conducted in the dry place, free from the dust, and voltage applied every after any air bubbles. The time involved shall be few minutes. Then the disperse of the air bubbles cannot be observed. Next. Transformer of the oil test. Solid materials and water molecules are the removed from the separators. Apart from the above the process, deaerations, filtration, and dehydrations are also carried out of the enhances the quality of the transformer oil. In small transformer purifications of the oil directly by the removing the once cleaning is completed. Oil the transformer using the filter plant for the large transformer without removing the oil. It made to the circulated through the purifier. This process is done without the engine the transformer. Next, inhibitors to the extend or daily the process oxidation substance like butyl para kerosene b short form is a DBPC are used. This process is called inhibiting an oil. By this process, the life of the oil can be extended by the 3 or 4 times the actual period. Next.
You guys have just 1 minute left. You can jump to the conclusion.
We have put a video for testing of transformer. Conclusion is the lubricants have a role to play in improve the energy efficiency of both automotive and industrial machinery. The technology to do this is well understood, although care is needed both by the machine designer and by the lubricant formulator to ensure that any reduction in lubricant viscosity does not result in decreased durability. One of the main reasons why such lubricants are not used more widely is that often lubricants are selected on the basis of their price alone without much regard for the impact of the lubricant on operating costs. So, a regular lubricant monitoring will ensure that machinery will run in good condition. Next slide.
Okay, it was a good attempt to present your topic. According to my understanding, your topic was related with testing of the lubricants.
Yes.
Am I right?
Yes, sir.
Yes, sir.
Okay, will you please tell me how to test the proportion of oxidation that has taken place in the oil?
Okay. There is a machine. So on that we have to put oil, and in which we have to dip a electrode, and from which we can taste the oil.
Okay, then how can I identify that oxidation has taken place to more proportion or some percentage, or it is in less percentage? Is it possible to understand that what is whether 50% oxidation or 30% oxidation or 80% oxidation?
Yes, we can understand.
Yes, yes, sir.
How because what you said that putting the oil in the machine and then we get the result, somewhere it is required to be interpreted. Okay, I have got one question, one more question. What is the use of that capacitance test? You said something like dielectric property. Okay, if you find it difficult, don't worry. Your presentation was good. Pradeep sir, it is your time now.
Sure. Thank you. Thank you, Rahul. Thank you, Ankita, for a good presentation. Just have a quick
Thank
question.
you, sir.
So, when you make blend any lubricant, the first property that people check is question mark, like fill in the blanks. Because if you buy, say, motor oil or any oil, motor oil will have a numbering saying that 5W30 or 20W50. What does it represent? And that is the first property that we check for any lubricant. So, do you know what it is?
No, sir.
Okay, sure, no issues. It's viscosity, and that's where everything begins. Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay, thank you. And next time when you're in a Q&A session, if you don't know the answer, be quick in saying that I don't know. All right. Okay. Let's head to our next participant, PPT 2221. You can start your presentation.
Good afternoon, everyone. I am Sritej Kandkur. I am currently studying a diploma in textile technology in SR Vastras Rural Polytechnic, Guledgud, Bagalkot, Karnataka. So today my topic is.
Keshu, are you going to present the screen or should we share the presentation?
Yes, sir. I will share the screen, sir.
Okay.
Is it visible, sir?
Yes, it is visible.
Thank you. So today I'm gonna explain you about the softening finishes for fabrics and garments. So let me introduce about my topic. That is first let me introduce about the finishing process. So what is the textile finishing? Finishing is the process given to the textile material before it is landed into the market. So we can expect some of the advantages from the finished fabric. that is the appearance and the feel and the durability of the textile fabric, which is come out from the finishing process. So the objects of the basic objects of the finishing is it has improved feel, that is we can say about the softness, fullness. So to have the special properties like the water repellency, and to have impressed wearing qualities like non-selling or the anti-crease property of the fabric, and to cover the faults of the original cloth also the finishing is processed. So the finishing is done to also to increase the weight and the increase the value of the product before it is launched in the market. And let me come to the my part of the presentation, that is softening finishes for fabrics and garments. So basically there are two types of finishing, that is mechanical finishing and chemical finishing. The softening finishes comes under the part of the chemical finishing. So let me introduce you the softening finishes. Softening finishes, these are the most important part in the textile after the treatments. And with chemical softeners, textiles can achieve an softness, soft handles, and the smoothness and the flexibility of bending, and the supple property of the fabric can be improved. The supple is the bending property of the fabric, and the plant is the easily bent property of the fabric. So the ability of bending of the fabric is known as pliability of the fabric. So it can be introduced by the softening finish of the fabric. So here in this softening process, the chemicals which are used to impart the desirable softeners in the fabric, softness in the fabric, those chemicals are called as softeners. And we can feel the softness of the fabric by touching the fabric by the fingers. So whenever you go to buy the cloth, so the first thing we observe, that is the fabric quality. So we can realize the fabric quality by just touching the fabric. So we can measure that by these physical phenomena such as elasticity, compressibility, and the smoothness of the fabric. So during the preparation of textile fabrics, the brittlement of the fabric takes place during the weaving process, and it will be contacted with some of the natural oils and waxes. So these are removed in the softening process. Finishing with softeners can eliminate these brittlement of the fabrics, and even they can improve the original suppleness. So as I said, the supple meaning is the bending property of the fabric. So the feeling of fullness will be added after the softening process, and it can improve that anti-static properties. So in our schooling days, we used to rub our scales on our head, and we used to just do like this on our hand, so that the hairs on our hand should attract towards the scale. So that is known as a static property. So it eliminates the static property in the textile material. That is, it can be done by the softening process. So as the advantages are always in some of the process, in the same process there will be some of the disadvantages also. So the disadvantages of these softeners are it reduces the fastness of the fabric, and normally in the white fabrics the yellowing takes place in the fabric. The yellow stains causes by this softening process, and it also changes the shade or color of the dyed goods. And some of the importance of the textile softening process is softeners and abrasion resistant finishes are added to textile structure to improve the aesthetics. So aesthetics means the beauty of the fabric. So it should be attractive that you should buy after seeing that fabric only. So it improves the attractiveness of the fabric. And as I said in the earlier, after the production of the fabric, there will be little brittleness of the fabric or harshness of the fabric. So by this process, by this softening process, we can also eliminate the harshness of the fabric, and we can convert that into the smoothness of the fabric. So it also improve the ability of the fabric, and it improves the abrasion. It resists the abrasion. It eliminates the wear and tear of the fabric, and it gives the durability to the fabric. The softeners are generally emulsions of oils or waxes. Emulsions means ready to use, which we can. The emulsion word is literally
Keshav,
heard in.
you have 1 minute left. You can jump to
Okay, sir.
conclusion.
Okay, sir. The effects of softening are the main effects of the main effects of the softening will be affected on the surface of the fibers, and there are four types of softeners: softeners and anionic softeners, non-ionic softeners, and amphoteric softeners. There are other softeners also. Those are silicone softeners, polyethylene softeners. So desirable properties of textile softeners are: it should be easily handleable, and it should have good compatibility to the other chemicals also. It should not affect the shade of the material or the color of the material, as I said. So it should not affect the fastness of the dyed material, and it should be stable to high temperature, and it should be non-toxic and non-caustic. So it should not be harmful by the gases, and it should also be biodegradable, which is sustainable to the environment. So the advantages of cationic softeners are, by applying the cationic softener, the fabric becomes soft and silky in handling the fabrics, and there will be good lubricant properties and positive effects on wet fastness, and we can also improve the tear strength of the fabric, and the sewability will be improved by this softening properties. So some of the
Keshav,
disadvantages are.
Keshav, your time is up. Let's start the Q&A session.
Okay, sir.
Keshav, you have explained.
Yes, sir.
You have explained softening finishes that can be given to the fabrics. Is there any mechanical method, means mechanical finishing, that we can offer to the textile material so that its feel can be improved?
Sorry, sir, I don't know the answer.
During your presentation, you said that the feel can be improved by two methods. One is mechanical and other is chemical.
Yes, sir.
Okay, so can you give me some example of mechanical finish that can be given?
So in mechanical finishes, there are two types of sub finishes. Those are temporary finishes and permanent finishes. So the temporary finishes can be done by the calendaring part of the finishing.
Right.
So and the permanent finishing can be done by the resin chanforizing and milling part of the finishing side.
Yes. What is chanforizing?
Chanforizing, it is normally done to the PC blends fabrics.
Achha.
The chemical which is used here is H2SO4, sir.
Okay. One more question.
Yes,
this anti-static finish is required to control the static formation.
Yes, sir.
Which anti-static finish is applied to the fibers when we are processing blends in carding department?
Sorry, sir, I have no idea about this topic.
In carding and drop frame, both the processes, when we are processing blend material, polyester cotton, polyester viscose. This is required.
Okay, sir.
Okay, no problem. It was a nice attempt. Kapadia sir.
Thank you, Keshav, for a good presentation. Just have one
Thank you,
question
sir.
for you. Uh, what are the advantages and disadvantages of, say, physical or chemical finishes? In which condition chemical soft finishes will be preferred, and under which condition physical will be preferred?
So, sir, as I said, in chemical finishing, there are again two types of chemical finishing. Those are reactive type and also the deposition type of finishing. In reactive types, we can finish the fabric in such different methods. Those are stiff and transparency and anti-shrink and flame retardant and soil retardant finishing can be given. And in deposition method, stiff finish can be given and freeze resistant and water repellent finish can be given, sir. According to our necessity, we can use certain finishes, sir.
Okay, thank you. Can you please repeat the presentation number again?
221, sir.
Okay, perfect. Thank you.
Thank you, sir.
Okay, let's head to our next participant, PPT 2224. PPT 2224. Will you be sharing your presentation or
Yeah.
should we present?
Yes, sir, we will, sir.
Okay, cool. You
Sure.
can start your presentation.
Yes, sir. Sure.
Turn on your cameras, please.
Okay, sir. So it's visible?
Yes, it is visible.
Good afternoon, everyone. I'm Venma and my teammate is Ashok Kumar. We are from Banariam Institute of Technology in Satyamangalam, and we are studying BTech Textile Technology first year. Now we are going to presenting here about advancement in oil and lubricants used in textile industry. Sure, next slide. Sure, next slide. Change mode. Okay, first of all, what is lubricant? A lubricant is a substance of, next slide, Ashok. Third slide. What is lubricant? Lubricant is a substance that helps to reduce friction between the surface in mutual contact, which ultimately reduce the heat generated when the surface move. The property of reducing is known as lubricity. Actually, lubricants have been in some use for thousands of years. In the Roman era, lubricants were based on olive oil and rapeseed oil as well as animal fats. The growth lubrications accelerated in the industrial evaluation with accompanying use of metal-based machinery. Next slide. Textile machine lubricants. Okay, there is a traditional lubricants have historically played an important role in the operating of textile machinery equipment. Today's world-class textile operations demand the highest efficiencies and quality of production, higher speed, longer runs between planned maintenance, and no tolerance for unplanned downtime. These demands require a world-class machinery design paired with today's world-class synthetic lubricants technology. Nylon lubricants has been developing and supplying the highest performance synthetic lubricants to mission critical industries and operations since the time of the double knit glacier shift. Check next slide. Next, textile lubricants. Textile lubricants used in the textile industry is called textile lubricants. Spindle oil, saving machine oil, soldier oil, dovey oil, needle oil, and knitting oil. Next slide.
Okay, which parts need lubricants and oil in textile industry? Okay, motor bearing gearings and draft frame top rollers, end bushes, and ring frame urban bearing, and ring frame urban bearing, and ring frame bottom flutter rollers, and high speed converse, ring frame spindles, knitting. Next slide. The use of fats and oils for textile. Fibers, yarns, and fabrics coming into the contact with the other surface undergo frictional heating under abrasive damage and often break, impairing the efficiency of the process. Sticking of the abraded materials to the processing machinery makes the situation worse. Triboelectric charging is also serious problem besides abrasion in the production of the processing of synthetic fibers. Charged fibers, because of the interfiber repulsion, do not form a coherent yarn, and it's difficult to wind such a yarns on bobbin to be transferred to other locations for further processing. To overcome these problems, combination of oils, fats, and derivatives of used extensively as lubricants and anti-static agents. Next slide. Textile finishing. Lubricants and oils not only used in machines, it's used in fabrics also. For what? For textile finishing process. The demand of the finishing of various textile fabrics to make them more marketable is increasing due to the global competition, and it has created many challenges to the textile researchers and industrialists. Fats and oils are commonly used in textile finishing process. The terms finishing covers all those treatments that improve certain properties or serviceability of fabric, for example, wrinkle recovering. One basic, okay, 6 vegetable oils used in textile finishing process: rapeseed oil, olive oil, coconut oil, linseed oil, modifying sunflower oil. Next slide. Ashwin. Okay, why we use oil and fat in fabric? Next slide. One basic approach to improving wrinkle recovery and producing wrinkle-reduced cotton fabrics that dominate the market is lubrication with softening agent. That is surface active agents, and hence a reduction in the friction coefficient between fibers, filaments, and yarns, resulting in the increasing flexibility and elasticity of the textile. Wrinkle recovery properties of cotton fabric. 6 vegetable oils: rapeseed oil, olive oil, coconut oil, safflower oil, and linseed oil, and modified safflower oil. With different fatty acid profiles were used. The result proved that the fatty acid profile is an important factor affecting the wrinkle recovering properties of treated cotton fabrics. In general, higher concentrations of the active agent provide better wrinkle properties for treated cotton fabrics. The results also suggest a better recovery from the wrinkle deformation is due to the formation of a microfilm around the fibers and yarns, the wrinkles, the friction coefficient. Previous slide. Okay. What are the challenges facing? Right. Okay. What are the challenges facing the textile industry? Changing atmospheric humidity, temperature fluctuations, and high loads are just some of the challenges affecting textile production. Textile industry wants to act in a sustainable manner to order to live up to its own entrepreneurial responsibility and protect the environment. Next slide. Okay, the final slide. Contribution of lubricants for advancement in textile industry. Lubricants are designed for...
Sorry to interrupt, but you have just 1 minute left. You can jump to conclusion.
Okay, so it's a conclusion, sir, actually. Okay. Contribution of lubricants for advancement in textile industry. Okay, what is the advancement? Okay, lubricants are designed for the needs of the textile industry. It is indirectly delivering increased productivity and able to produce product in specific quantities at specific time according to customer requirement. Next slide, Ashok. Okay, Okay, thank you for giving opportunity and thank you very much for your unwavering attention throughout this presentation. Thank you, sir. Thank you all.
It was a nice presentation.
Thank you, sir.
Mr. Venma and Mr. Ashok Kumar. I didn't listen anything from Mr. Ashok Kumar. Okay, let us now. I will talk to him. Here in your presentation, there is a specific mention of spindle oil, knitting oil. Which oil is used for spindle of the ring frame? If possible, you can give me the name. If not possible, you can give me the important property.
We have no idea, sir.
Okay. What is the viscosity of spindle oil?
Sir, once more question, sir.
Yes, I want to know what is the viscosity of spindle oil used for a ring frame spindle.
Hmm.
See, the lubricity word you have used in your presentation, that
Yes,
is
sir.
related to viscosity of the oil.
Yes. Um, no idea, sir.
Okay, no problem. You said that linseed oil is also used for finishing of the fabrics, means textile products.
Yes, sir.
What is the effect of linseed oil? You have mentioned 4 5 different oils, but
Yeah, yes, sir.
I want to know about linseed oil.
Um, linseed oil is flaxseed oil, sir. Linseed oil is flaxseed oil is known as is a colorless to yellowish. This is flaxseed oil, sir. Right.
Okay. Dr. Pradeep, over to you.
Okay, sir. A good presentation, Venma and Ashok. Just one question. You said different vegetable oils are used in this case. So, what would be the advantages and disadvantages of using vegetable oils here?
Disadvantage is become a machinery problems.
Sir, advantage is better lubrication, sir. Motor oils first and for more task and lubricant the running parts. The engine components are exposed to grueling temperatures and obtain the gradual wear and tearing. Engine clearing engines are used for cleaning engine and reduce the friction and reduce the heat. It's advantage, sir.
Okay, thank you.
Thank you, sir.
Okay,
Thank
thank
you,
you so
sir.
much. Okay, let's head to our next participant, 2203. You can start your presentation. Double 203.
Sir, just a minute.
Yes, sir.
Okay, turn on your cameras and would you like to present or should we share our screen?
Sir, we will present, sir.
Okay, cool. Turn on your cameras, okay?
Sir, is it visible, sir?
Yeah, it is visible. You can start.
Shall I start, sir?
You can start.
Good afternoon.
Good afternoon to one and all present. Mute பண்ணிக்கோ.
Good afternoon,
Good
one and all
afternoon to one and all
present here.
present here.
I,
This
Sapna
Sapni
Shani,
Shani
and
and
my
my
friends
friends
Satya
are
going to
going to
present
present
today's
today's
today's topic. Camera on camera off. Off பண்ணிட்ட பிரபு. Sir, is it audible, sir?
Yes, you are audible.
Okay, sir. Sorry for the misconceptions. Good afternoon to one and all present here. I am Saffron Shani and my friend Satya are going to present today's topic about innovations in softening finishes for fabric and garments. Next slide. Abstract. Technical textile in particular are subjected to several processing and finishing operations which may make the material harsh or brittle. Softening is therefore as an important class. Softening treatment is critical. Otherwise, the softener itself may impact the functionality of technical product. This presentation discusses the mechanical, enzymatic, and chemical methods. We have taken last slide. The effect of softener application on the physical properties, color, whiteness, handle, and flammability of textiles are included. By creative innovation, we added the advances of softening finishes, research in softening finish of khadi fabrics. Next slide, please. Introduction. Softening finishes are the most important chemical after treatment. With chemical softeners treatment, textile can achieve an agreeable soft fan and some smoothness, more flexibility, and better drapement playability. The hand of fabric is a subjective sensation felt by the skin. When a textile fabric is touched with the fingertips and gently compressed, the perceived softness of a textile is the combination of several measurable physical phenomena, namely compressibility and smoothness. Next slide, please. What is a softening finishes? Softening is an auxiliary that, when applied to textile material, brings about an alteration in the handle, resulting in the goods being more pleasing to the touch. Softening finishes are among the most important of textile chemical after treatment. It is generally defined as the process of modifying the handle or feel of textiles for better comfort, better wear, or performance under defined conditions of use. It is a phenomenon of associated with modification of surface properties of textile described in terms of handle, volume, softness, and drape. Next slide, please. Objective. It should be easy to handle. It should have good compatibility and other chemicals. It should not affect the shade of the material. It should not affect the fastness of dyed material. It should not cause any yellowing effect on dyed and finished material. It should be stable to high temperature. Next slide, please. There are 5 types of softness. They are non-ionic, atmospheric, cationic, silicon, and anionic. First, I'll say about anionic. They have good characteristics as they, um, they have good characteristics as the lubricating softening agents. Give a fabric full lead. They are unusable in hard water and acid environment. Non-ionic softener. It is applied to synthetic fiber and their bleach hot water should not used during the application of non-ionic softener. Atmospheric amphoteric softeners. The softeners are designed for white with excellent revealing and low yellowing properties. This finishing agent for soft, fluffy handle with inner softness, all type of substrate. Silicone softeners. The software that require no additional catalyst or cross linkers to form. Durable silicone cleaner, cationic softener. They are molecules that have a positive charge on the hydrophilic end, which are amine and quaternary ammonium salts. Next slide, please. Recent advances in softening finishes. Encapsulated softeners to obtain longer lasting softening effect. Slow release of softener without excessive deposition is expected, which can be provided by encapsulated softeners. These softeners are encapsulated in a non-staining protective coating, which allows a slow release of softeners. Temperature regulating textiles normally make use of phase change material to control body temperature. Fragrance and softening. It is quite common for fabric softeners to be mixed with aroma chemicals so that fragrance will as well as the softness is imparted to the textile material. To overcome the problem of gelling of the softener in a mixture, a method describes a method of controlling viscosity of a fabric softener by preparing a mixture of fragrance chemical and a surface active agent. Next slide, please. Flame retardancy and of silicone finishes. They show slow burning with no toxic emissions and thus complement flame retardants. The silicate residue of silicon co-burning offers an insulating blanket. Silicon offers a heat-resistant coating because of PBMDS stability
Sorry to
up to
interrupt.
300.
You just have 1 minute left. You can jump to conclusion.
Over to Satya.
Yeah, next is Cori fabric by softening treatment. Cori fabric is also known as other name of Codar. It is 100% pure and it is almost a natural and it is made up of a pure cotton. But it also has some have some disadvantages like wrinkles easily and it has poor color fastness and dimensional stability and durability property. To overcome this, it is treated to a softening treatment. The first treatment is a procurement of fabric. In this, the fabric suitable for the research were collected. The collected fabrics were screened depending upon their texture, hand evenness and compactness of the weave and uniformity of the yarn. Cotton khadi fabric exhibiting medium weight was selected for this. And second process is the procurement of commercial softeners. They used three types of softeners, namely Abrosol, Abrosol Redico, and Abrosol Nickel. These were selected for the testing softening finishes of khadi fabric. Next is a pre-treatment of the cotton khadi fabric. To ensure complete wetting and uniform absorbency of the softening agents, the cotton khadi fabric was subject to a preparatory process. Deicing and scoring treatments were given to the fabric to remove foreign materials before importing the finish. Enzymatic next is the enzymatic deicing and scoring. The cotton khadi fabric was deiced with 2.5% on weight of the fabric with 60 degrees Celsius and enzyme amylase was used.
8 minutes are up. The Q&A session can start. So,
You were explaining to finishing given to the khadi fabric.
Yes, sir.
We started with a topic that is related to softening treatments. And softening, is it required for khadi fabrics? Because khadi fabric basically is compressible and soft.
Sir, but the consumers are expecting for the more smoothness and hand feel fabric to wear. Yes, no, sir.
Acha, so I was under impression that it is required for anti-crease and such type of finishes are required for khadi fabric. Softening is not much critical. Okay, let it be. Flame retardancy, that finish requires the use of chemicals containing halogens. Halogen derivatives are required. You said that it is silicon.
Yes, sir.
Silicon is also used for flame retardancy, but which is more beneficial, whether this halogen type or silicone type?
Halogen types.
Okay. Pradeep sir.
Yeah, thank you. Thank you for a good presentation. An interesting point that you brought up was about encapsulation of softener for durability. So encapsulation usually it's like capsulated finishing agents, but under which condition this encapsulation should break? Have you ever considered or thought about it?
Sir, no idea, sir.
Sure. Think about the process where finishing takes place, and under specific condition, the encapsulation will usually break and release the finishing agents. No issues. Thank you.
Okay, sir.
Thank you, sir.
Thank you, sir.
Okay, let's head to our next participant. 2229. PPT 2229. You can start your presentation.
Yes, are we audible?
Yes, you are audible. Can you turn on the camera, please?
Yes.
Okay, cool. Should we present or are you going to present?
We are going to.
Okay. Okay.
Good afternoon, ladies and gentlemen. Myself, Sanskar Mangave, and my colleague Anuj Jain represent Decade Institute. We are here to talk about conservation and sustainability of oils and lubricants.
Lubricant, it is a substance that helps us to reduce the friction between the surfaces in the mutual contact, which ultimately reduces the heat generation of the moving surfaces. The oil, it is a non-polar chemical substance that is composed of primarily of hydrocarbons, and it is hydrophobic in nature and lipophilic in nature. Sustainability is a key for the better future. Humans rely on the natural resources for their business activities and their daily lives. There are many definitions for the sustainability, but UN defined it as meeting the needs of the present without compromising the ability of the future generation to meet their own needs.
The world will only achieve sustainable future if investments made are sustainable themselves. Why we need sustainability? To reduce emission using effective lubricants and engine oils result into saving in emission and cost. Second, biodegradable. Biodegradable lubricants such as synthetic or vegetable oils are much more considerable to the environment and are less toxic to plants and animals. Third, improvement in three different dimensions such as economic growth, social inclusion, and environmental protection. Fourth, and most important, extending the use of valuable resources for the upcoming generations. Today's wastage is tomorrow's shortage. Natural resources are limited and we don't have a planet B. So considering this, we need to conserve current rate of consumption. Reserves will last or sustain not more than 40 years. Second, climate change. Climate change is a big concern as it creates a greenhouse effect and all other circumstances. Third, pollution. Pollution is also the one of the biggest problems in the today's century. The great threat to health of humans and animals, which is also a priority question. Fourth, non-renewable resources. All these oils and lubricants are a part of oils, and as the oil is a non-renewable resources, it takes millions of years to further formation, and excessive use will not sustain longer.
The total global demand for the lubricants in the 2020 has reached at its peak, where the demand has reached for 37 million metric tons. This is a great amount. By 2050, if nothing is accomplished, only in textile industry, we will be using 300 million tons of oil, which is approximately 9% of all man-made carbon emission. For this, we can what we can do related to textile industry: using of synthetic lubricants, use of eco-friendly lubricants, and use of biosynthetic oils. Special lubricants generate positive effect. The properties for these lubricants are: they reduces the frictional resistance, they reduces the emissions, save natural resources, improve the environmental compatibility, minimizes cost of disposal, extend the service of life for the machines, and reduce the operating cost. Meeting objective related to textile sector. The concept of sustainability and energy efficiency are gaining importance in textile industries as the margins in the textile industries are reducing day by day. More than ever, this industry is looking forward ways to attain a lower energy consumption, and this can be achieved by making machines more effective, extending life time of components or lifespan of components, as well as more maintenance intervals. The added benefits of such measures is reduction in operation cost. Oils have to be certified as carbon neutral to the BSI PAS 2060 standards, British British Standard Institute. The use of high quality spindle oils will not only contribute to a smooth functioning of the spindles, but also allows for the extended lubrication intervals as well as reduction of energy consumption. A particularly a positive effect can be noted when worm gears are switched over to polygonal oil. Their efficiency has been increased up by 35%, ultimately cost saving and ultimately more sustainable. Synthetic lubricants have proven to reduce the energy cost and in addition extend the service life of gears. This all results in saving of both in terms of financial resources and energy. Besides these savings, operations enjoy the benefits of a much better CO2 balance in their operations. Rather than this, becoming a carbon neutral or carbon negative is also a way to move sustainable. Thank you for your attention.
Your presentation was slightly different. It was good. The strategy that you have followed for presenting is different, and I liked it.
Thank you, sir. Thank you, sir.
Okay, you said that use of high quality spindle oil. What is meaning of spindle oil? Means what oil, which oil we use as a spindle oil, and how it can be improved by means of high quality.
High quality can be related such as using of 100% synthetic oils, which is a product of total energies, which increases the re-lubrication intervals as well as they are more corrosion resistive, and this all ultimately results into cost saving and ultimately a more sustainable in nature.
Achha. And then somewhere you mentioned for worm and wormwood, polyglycol is to be used. What is this polyglycol and what is its main property? Why it is accepted as a lubricant?
Sir, we don't know the technicals of the polyglycol oil.
Okay, Pradeep sir.
Thank you. It was really wonderful presentation, different from what we have seen so far. So the question that I have is, everybody or all the companies, even countries, will have carbon neutrality targets.
Yes, sir.
So
Yes.
in case of textile industry, how do you think we can achieve it? One option is to use renewable compounds, of course.
Right.
But apart from lubricants, what are the other fields where we can think of using
So
carbon neutral?
if we consider the topic about the textile industry, it should be start from the initial energy consumption as well. Means it will start from using the renewable energy such as solar, wind, and hydropowers, rather than using energy generated from coals or nuclear power plants. Second, using effective motors and high technology to reduce the energy consumption. Second, and third, ultimately will be the lubrication and Quality checking of the oils. Right. And scheduled maintenance is also one of them.
Sure. Thank you. Thank you so much.
Thank you so much. Okay, let's head to our next participant.
Thank you.
PPT
Thank you.
double 217. Double 217, you can start your presentation. Omkar, would you like us to share your presentation or will you be sharing your screen?
Yes, present. You can present.
Okay. Just a second, Omkar.
Yes. Good afternoon, everyone. My name is Omkar Ramakant Gige. I am here to present a topic invention in softening finishes for fabric and garments. Next slide, please. What is innovation? Innovation is the key of factor to achieve success in market. Innovation can refer to something success in market, to something new, such as an invention or the practice of developing and introducing new things. Next slide. Innovation in textiles. First point is microfibers. While cotton is natural fibers, microfiber is made from synthetic materials, typically polyester, nylon blends, etc. Microfibers is very fine, as much as one one hundredth 100 the diameter of the human hairs and one-third of the diameter of cotton fibers. Microfiber is widely used by car dealers to handle tasks such as removing wax from the uh, paintwork, quick detailing, interior cleaning, glass cleaning, and drying because of the fine fibers which leave no dust or lint. Next point is bamboo fabric. Bamboo fabric is a biodegradable. It is softer than silk, making it one of the most comfortable materials. Uh, it is also antibacterial resistance to wrinkles and has eco-friendly. It is not any breathable but also protects against UV rays. Bamboo fiber clothing is a lightweight and breathable, making it ideal for uh, hot weathers. In chemical process, bamboo leaves and woody shoots and dissolves using strong chemical solvents like sodium hydroxide and carbon disulfide. Third point is lycocells. It is made from pulp from trees grown in replanted forest. It is regenerated fibers. Lycocells material offers great strength and elasticity. Lyocell is so soft to the touch, comfortable and breathable. In Lyocell process to dissolve the cells with the help of N-methyl morpholus N oxide are used. Next point is biocotton. Biocotton is cotton that has been grown organically. It avoid a lot of environment uh, and environmental problems. Nanotechnology. It is a molecular structure of the chemical used to form fiber has been altered. Nanotechnology is incorporated into wave of the fabric or spread onto its surface. Create a create a coating that repels water and stain product liquids. Next slide. protective wears from insect repellents, antimicrobial, ultraviolet protection, radiation protection, anti-static, and electrically conductive. In insect repellent textiles protect human being from the bites of mosquitoes, thereby offering safely from mosquito-borne diseases such as malaria and dengue, etc. Antimicrobial finishes. A number of antimicrobial agents uh, are now in the market that can kill the bacteria and enable textiles and garments to remain fresh and longer. Ultraviolet protection. Textiles have been used for protection against solar radiation since the time of ancient civilization. Textile structure, unique characteristics required for a sunscreening apparel, anti-static and electrical. Next slide. Next slide. This is the graph of the textile plant, full textile plant. This is 40% of finishing process. Finishing process is the main process of the textiles. Next slide. What is impact on environment? Everything has its own pros and cons. Like in improving finishing and softeners, we can use advanced chemicals. This is we can not completely destroy or not completely use in the form. This chemical is through in rivers like that, so we can adjust these chemicals. Next slide. Thank you.
Omkar,
Yes, sir.
it was a good presentation. I want to know why bamboo fibers are having inherent antimicrobial property. Any reason for that?
Sir, 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 after the this is the structure like no idea, sir.
Okay, no problem. You said that anti means insect repelling finish can be given to the fabrics. What is the life or durability of such finish? Is it there permanently or it is for limited period?
Sir, it is for limited period after washing cloth again and again.
Acha. So after how many washes the effect completely vanishes?
Sir, this is not decide how after wash matlab means like 3 to 4 years.
Acha.
We can use this fabric.
Okay. Which material, which chemical we use for making the fabric insect repellent?
No, sir. We can use chemical like DEET, DEET. It is extremely used in the fabric, on the fabrics.
Acha. Okay. Now over to Pradeep sir.
Thank you, Omkar. Just have one question. So, if you have fabric from bamboo, how its treatment, how it is prepared, the bamboo fabric?
Sir, sir, structure of the pulp, sir, surface of the pulp bamboo.
Not structure of the pulp. From pulp, how its treatment differs from treatment of say other type of fabrics or fibers?
Don't know, sir.
Omkar, can you switch on the camera?
No issue.
Yes,
Thank you so
yes.
much.
Thank you so much, Omkar. Thank you so much, judges, for
Thank
your
you.
cooperation. Now we will have a small break and we will be continuing this event on 2:30. By 2:30, we will be continuing this event. Thank you so much.
Okay, okay. Thank you.
It is request for it is request for every candidate. Please join 5 years prior, 5 minutes prior.
मेरी बॉटल गिरी मेरी बॉटल
Okay.
सब उसको सुलाता हूँ, तुम जाओ फिर मैं सब कैरेटिन 3999 में है। तीनों नॉर्मली कितने का होता है कैरेटिन ट्रीटमेंट?
6000 लेंथ फिर होता है, जैसे 3999 है फ्लैट, एनी लेंथ में होगा, जो 3999 है। अब मेरे में थोड़ा 500 बढ़ेगा, जिसका इतना होगा तो फिर उसको
जाके करा क्या तुम्हारे जाने से पहले? ये कैथलिक है क्या? शुमाना A404? शुमाना AA404, उत्पल की बीवी।
सोना कैसी है बंगाली है तो
बंगाली क्रिश्चियन है क्या? हर ऐसे क्रिश्चियन वाले वो अपडेट कर रहे हैं, इसलिए बोल रहा हूँ।
वो साइकोलॉजी में उसमें है ना, अपनी रिसर्च जो करती है उसमें वो सब वही अपना रोज का पोस्ट करती है।
प्रदीप
रिसर्च वाला नहीं है, रिसर्च किसी साइंटिफिक फील्ड में है।
ये रोज ये इसका एक
एक्सक्यूज मी
हाँ, ये
प्रदीप सर,
वही बोल रहा हूँ, ये बाइबल से पोस्ट कर रही है और उसके
पर ये
रिसर्च
है नहीं
में
वो प्रॉपर बंगाली।
प्रॉपर बंगाली भी क्रिश्चियन होते हैं।
हाँ लेकिन वो नहीं है भाई, मैंने को उनके घर की फोटो वो सब देखा है मैंने, वो वैसे नहीं लगे हैं।
अभी मंडे को ही टीचर का जल्दी से जल्दी रिस्पॉन्स आएगा। मुझे तुम्हारी ना ये स्टूडेंट्स हैं ये સુધી बहुत जना ठिकाने वाला लग गया टोटल 22 मिनट।
एक्सक्यूज मी प्रदीप सर,
એટલે જે કે શોર્ટલિસ્ટ करा આગળ વાત करेला પણ એ डाइंग
मतलब जॉब के लिए
ऐसे भी इंटर्नशिप के लिए जॉब तो तेरी झलक शर्फी श्रीवल्ली आजकल N90 तो बाजार जा रही N90 तो पहन लो ना, एटलीस्ट सर्जिकल पहन लो।
भीड़ नहीं होती मैं
एटलीस्ट सर्जिकल पहन लो।
मैं ऊपर नीचे बिल्कुल नहीं करती।
हेलो
नमस्ते सर, आपका माइक ऑन है, तो आप जो भी बात कर रहे हैं वो इधर सुनाई दे रहा है, बाकी के बहुत लोग हो सकते हैं। सो आई हैव ड्रॉप्ड ए मैसेज ऑन व्हाट्सएप आल्सो। अच्छा सर, प्लीज ओके।
So, good afternoon, guys. We are going to start within 5 to 10 minutes. Just for confirmation, may I know that PPT 2201, PPT 2233, PPT 2234 are there on the group? PPT 2201, PPT 2233, and PPT 2234. If you are there, just let me know.
हॅलो जोशी सर.
हा बोला राजेंना सर.
सर झालं काय लंच?
हा झालं की.
ओके ओके ओके. आता कपाडे सर पण असणार असेल इथं.
हो आहेत, ते जॉईन आहेत इथं.
हो आहेत, दिसतंय, नाव दिसतंय. एक 5 मिनिटात चालू करा, 5 ते 6 मिनिटामध्ये.
काही अडचण नाही, आम्ही आहोत.
ओके ओके.
Hello, Sanwar. Can you hear me? Sanwar.
Hi, yes, Tanjir.
Hello, Sanwar. Can you hear me?
Yes, you're audible.
Hello, Sanwar.
Joshi sir and Pradeep Kapadia sir, are you guys ready? Can we start?
Yes, please.
Yes, I am here.
Okay, our next participant is 2201. You can start your presentation. Just a second, we'll stop the presentation. Just a second. Okay, you can start now. 2201.
Yes, sir. Good morning. Sorry, good afternoon. Sir, we have a network issue. So, can you present our presentation, sir?
Yeah,
Yeah,
sure. We'll
sure.
present.
Yes, thank you.
Bhavya, can you turn on your camera?
Yes, sir. Thank you. Good afternoon, one and all present here. Our team topic is innovation in softening finishes of fabrics and garments. My team members are Bhavya Mailsami and myself, Bhavya Pandian. So, we are from Kumaraguru College of Technology. Slide change sir, to the introduction slide. Textiles and clothings are the basic needs of human life for protecting themselves from climatic conditions. And thus, as technology improves, we know that people's method and quality of life improves, and so textile and the clothings are expected to offer more than their original properties. In this modern days, consumers not only demand good quality textiles and apparels, they also expect these to be trendy and to have some specific characteristics. And all the fabric should meet these basic requirements like functional and the physical properties, and to be finished with different kind of finishing techniques. Mechanical and chemical process done in manufactured fabric before cutting and sewing is called as textile finishing. This textile finishing process of fabric modifies the final appearance of manufactured fabric, like making it softer, improving the elements of its performance, and making it look presentable and unique. This process is used to achieve desired effects and to have aesthetic and functional benefits. There are so many types of textile finishing, like anti-static finish, crease resistant, pulling, shrinkage control, water repellent, and waterproof, etc. In these types of finishing, softening is one of the type of finishing which makes the fabric softer in different methods. Here we see a detailed process and innovations made in softening processes. So let's see what the softening finishes. We all know no garment is bought in the store without touching it. All other qualities being equal, the softer feel of the fabric will be unique selling point that will make the customer's decision to purchase it. It is for this reason softening finish has become the important stage. Softness is considered to be the dominant factor in offering comfort. Natural fibers themselves contain natural softeners such as wax and oils, but during pre-treatment process, these are removed, making it less soft and sometimes harsh or brittle. This creates the need for a subsequent finishing process with added softness. Textile softness is defined as a chemical or blend of chemicals that, when applied to textile materials, brings a change in the handle that is more pleasing to touch. And softness is selected based on the extent of softness and the aesthetic properties they provide. Over to Bhavya Melsami.
Here we see the mechanism of softness. Softness provides the main effects on the surface of the fiber. Small softener molecules perforate the fiber and provide an internal plasticization of the fiber forming polymer by reducing the glass transition temperature. Cationic softwares direct themselves to the positively charged ends towards the negatively charged fibers, creating the new surface of hydrophobic carbon chains, which provides the excellent softening. On the other hand, anionic softness direct themselves with the negatively charged fibers. In a result, it will lead to higher hydrophobicity but less softening than with cationic softness. The orientation of the non-ionic softness depends on the nature of the fiber surface, with the hydrophilic portion of the softener, which is attracted to the hydrophilic surfaces, and hydrophobic portion attracted to the hydrophobic surface. Next slide, sir. Here are the types of softness: anionic softener, cationic softener, silicon softener, amphoteric softener, and non-anionic softener. Bhavya Pandyan will explain the advancements in softening finishes.
So let us get into the innovation in softening finishes. So there are 5 types, 5 and more than that. So encapsulated softness, fragrance and softening, easy care or softness challenge, flame retardancy of silicone finishes, and hydrophilic silicone softness. So the first one is encapsulated softness. To obtain a long elastic softening effect, slower release of softener without excessive deposition is expected. That is provided by the encapsulated softness. These softeners are encapsulated in a non-staining protective coating that allows slower release of softener as per US pattern. Textiles which regulates the temperature make use of phase change material to control body temperature. In the absence of encapsulated softeners, hydrophilic softeners are needed in order to progress the sweat from the skin and manage the moisture. Next slide, please, sir. Next slide. And next. So the next slide will be explained by Bhavya Melsami.
The second softening finish is fragrance softening. It is the most common softener which is mixed with aroma chemicals, which is nothing but which imparts odor as well as softness is imparted to the textile materials. The problem of the gilling of the softener in the mixture is overcome by the method of controlling viscosity of the fabric softener by preparing the mixture of fragrance chemical and a surface active agent. This mixture is then added to the fabric softener base formulation to produce the softener which can be used by the consumers. The third one is easy care or softness challenge. Conventional fluorochemicals in parts stain repellency, but they are harsh to touch.
So, amino-modified silicons become the natural choice because of their ability to obtain a high degree of softness. When both put together, the softness is nevertheless obtained at the cost of strain release, and strain repellent properties is found. Organo-modified silicons are recommended in cases where both the properties are required. These are the silicon copolymers. This contains the hydrophilic groups such as polyalkyl oxide polymers and additional amine or amide or epoxide groups which offer the reactivity so that durable softness is imparted. Some functional but cleavable water-soluble silicons have been reported which are stable under the neutral or alkaline conditions. The cleaved surface bear the siloxane functional group that imparts water repellency to nylon fabrics.
So next slide, please. So the next type is flame retardancy of silicon finishes. Statistics say that over 70% of the fire deaths in dwelling are caused by the textiles. In many cases, to prevent fire and save lives, it is needed to give fireproof properties to textiles. So flame retardant finishes is one of the most important finishes among the various finishing of textiles. Polysiloxanes are considered to be stable at high temperatures. They show slow burning, no toxic emissions. Burning with no toxic and thus complement flame retardants. The silica residue of silicon on burning offers an insulating
Interrupt,
that.
but you just have 1 minute left, so you can jump to the conclusion.
Okay, sir, thank you. So the conclusion is, in general, as far as softness and substantivity are concerned, cationic and silicon softeners are the most useful. Polyethylene competes with silicones in offering the best lubricity, and anionic and amphoteric softeners distinguish themselves by offering hydrophilicity. Choosing proper mix of these softeners is very important. The different characteristic of different softeners, ionic nature, emulsion stability, volatility, etc., become quite crucial factors when making recipes for applications on textiles. Selection and application of softeners become even more complex when blends of different fibers are used in making fabrics or garments. Since the final hand of the fabric plays a crucial role in influencing the decision of the consumer, softening finishes are always going to be among the most important finishes for textile and apparel. Naturally, the research in this area will continue to gather impetus in the quest to improve selection of blends of softness and their performance and durability. To overcome the problem of the migration and adverse effects on crop fastness and to reduce the environmental impact. So here are the references links. Thank you so much.
Thank you, sir.
To Bhavyas, it was a informative presentation. I have got one question for you.
Yes, sir.
What is the role of polar molecule in amphoteric softeners?
Sir, again, sir?
What is the role of polar molecule in action of amphoteric softeners?
Itu sir.
In your slide, it was mentioned that different types of softeners are there. Among
Yes,
that,
sir.
one is amphoteric softener, and it has polar molecule in the long chain organic compound. What is the role of that polar molecule?
Can you please turn on the cameras?
Please turn on your cameras.
There is a particular role played by that polar molecule in the organic compound, which facilitates the softness. What is that role?
What molecule? I couldn't get you clearly, sir.
Polar molecule, POLAR
Yes, sir.
molecule.
For rewetting, sir.
refitting to. Okay, leave it. Pradeep sir, it is over to you.
Thank you. Thanks for a good presentation. I have the fragrances in softener. Typically, how long does this fragrance last if it is added to the softener?
Sir, based upon the usage, sir.
So, but not for so long. It is based upon the fabric and the usage of the fabrics.
Okay, sure. Thank you.
Shivtej, next presentation.
Yes, sir. Yes, sir. Next presentation is of PPT 2233. You can start your presentation. 2233. Okay, he's not present here right now, so we'll head to next one. Next one is 2234. 2234. Tanjir
Hello,
Ahmed.
sir. Yes, sir.
Yes, you can start your presentation now.
Yes,
Will
sir.
you be sharing the scene or we should share our screen?
Should we present from our end or you are going to present over there?
Hello, sir. Hello.
Yeah, you are audible.
Yes, Anwar. Please share the screen.
Skin. I already skin, but
Should we
share
share for
screen.
you? Should we share for you? We have your presentations with us.
Hello, Anwar.
Yeah, sir. That's it. Tanjir, please start. Tanjir. Hello.
I cannot see your presentation slide.
Slide. Skin আছে skin.
I cannot show it. Okay. Let's start. Good afternoon, everyone, and welcome to our presentation. Firstly, let me thank you all for attending this program today. Now, this is Tanjir Ahmed, student of North University, Bangladesh, and my friend Sanwar Hussain. He is also a student of Northern University, Bangladesh. Me and my friend Sanwar will discuss this presentation. This presentation will to divide. I will discuss about softening, softening finish, softening type, softening mechanism, and other parts. MD Sanwar will describe carried out at the rest. What is softening finish? Softener is an auxiliary that when applied to textile material brings about an alteration in the handle, resulting in the goods being more pleasing to the touch. Softening finish are among the most important of textile chemical after treatment. Next slide. What is softener finish? Mainly softener are three types: anionic, cationic, non-ionic. There are many different types: silicon, such as silicon, anthropores, the multi-softener, etc. Anionic softener, anionic softener are produced by the condensation of fatty acid. They have a good characteristic as lubricating, softening agent and give the fabric a full hand. They are unstable in hard water and acid environment. Cationic softener. Cationic softener are molecules that have a positive charge on the hydrophilic and which are amines and quaternary ammonium salts. Non-ionic softeners. Non-ionic softener is widely used on synthetic fiber and their blend. It is compatible to. Next slide. Mechanism of the softening effect. Softeners provide the main effects on the surface of the fiber. A small softener molecule, in addition, penetrate the fiber and provide an internal plasticization of the fiber, forming polymer by reducing of the glass transition temperature. The physical arrangement of usual softener molecule on the fiber surface is important and shown figure. It depends on the ionic nature of the softener molecule and the relative hydrophobicity of the fiber. Here are the mechanism of softeners. Other slide. Next slide. Cationic softeners orient themselves with their positively charged ends towards the partially negatively charged fiber, creating a new surface of a hydrophobic carbon chains that provides the characteristic excellent softening and lubricity seen with cationic softener. Anionic softener, on the other hand, orient themselves with their lead to higher hydrophilicity, but less softening than with cationic softener. This leads to higher hydrophilicity but less softening than with cationic softener. The orientation of non-ionic softener depends on the nature of the fiber surface, with the hydrophilic portion of the softener being attached to hydrophilic surface and the hydrophobic portion being attached to hydrophobic surface. Sanor will describe the next slide.
Yes, sir, good morning. Good afternoon, everyone. Please, next slide. Silicon softener. Silicon, particularly amino-modified silicon, are well recognized as premium fabric finishing agent, as they not only provide im- surface softeners but also improve many fabric physical properties. And here the some articles for a silicon softener. Please, next slide. Next slide is given to slow on a silicon softener on polar fiber. And these bonds act as an anchor for free silicon, which forms an inventory divided from on the fiber surface. Good water repellency and very soft hearted are the result. Please, next slide. Next slide, please. Advantage and disadvantage of silicon softener. Here the disadvantage and advantage of silicon softener. Advantage of silky handed on all fibers, water, clear oils, and stable for heat and light, and other disadvantage of great water repellency of some types and making them unsuitable when asymmetry is required, cannot easily be removed for
Sorry to interrupt.
redying.
Last minute is left, so you can jump to the conclusion.
The conclusion is described Tanzir Ahmed. Tanzir, please describe it.
Theta test and ultra soft touch. Theta touch and ultra soft touch finish are commercially produced by dating with amino carboxy or epoxy silicons alone or in successive treatments. Amino silicons are widely concentration 2.5 to 3% on weight of fabric in garment finishing, yielding and some level of hydrophobicity are the disadvantages. Epoxy silicons, which are most comfortable with most of the other finishing chemicals, impart softener without yielding and improve fabric strength. They also play a vital role in wrinkle-free finishes by importing.
Ahmed, sorry to interrupt again, but your time is up. Let's move to the question and answer.
Tanzir, it was a good presentation. Will you please tell me what is the difference between action of cationic softener and anionic softener? How they provide softness to the fabric? Cationic and anionic.
So actually, cationic has cationic has positive charge and anionic has negative charge.
Right. Okay, Sanwar, what
Yes,
are
sir.
what are limitations of silicon type softeners? Limitations or disadvantages?
Actually, silicon-based softener oxygen demands is alternative uh, organic organic group of attached to silicon.
Okay, ठीक है. Over to Pradeep sir.
Thank you. Thanks for a nice presentation. Just have a quick question. So, when you talk about silicone softener, the primary task will be softening the fabric for a feel. But apart from that, silicone softener, what other functionalities can be imparted to the fabric using silicone softener?
Sorry, sir.
Apart from softening, what other functionalities can be imparted in a silicone softener?
Sorry, sir. I have no idea.
All right, no issues. Thank you.
Okay, sir.
Thank you
Thank you.
so much, Anur and Tanjir. Let's head to our next presenter, 2230.
Thank you, sir.
PPT 2230. You can start your presentation.
Yes, I'm here.
Okay.
Just turn on your camera before starting a presentation. Are you presenting from your own end, or we have to present?
I'm trying.
Yeah, okay, fine.
Can you see my screen?
Yeah, it is visible.
Is my presentation is seeing now?
No, your PPT is not visible.
Okay.
Should I present from my end?
Yes, you can. Good afternoon, everyone, my dear judges and other participants. Here is my PPT. Please, next slide, please. PPT 2230. I'm Maria Afrin from Northern University, Bangladesh, Department of Textile Engineering. My presentation topic is innovation in softening finishes for fabric and garments. Next slide, please. Here is the softening with hand touch figures. And next slide, please. Softening of textile, softening the treatment which makes the fabric more flexible and impact the impression of softness are known as softening. Softening generally comes from making of the fabric more flexible and decreasing interfiber frictions. Softness of the fabric can be enhanced by chemical or mechanical treatment. Next slide, please. Here are some characteristics of softening. Low viscosity liquid softeners produce a flexible and silky handle. Solid softeners provide lubricant properties. Next slide. The hand imparted and the property of softening agent depends on the physical state of the softeners, the chemical and natural and the behavior of the fabric. Softeners are sometimes implicated in quality and the environmental problem. The tendency of some softener to develop a yellowish color which is undesirable, especially in white fabric. Next slide. Types of softener. We see here some types of softener. One is anionic softener, which is negative softener, and cationic softener, which is positive softener, and non-ionic softener. Next slide, please. Reactive softener and amphotic softeners and silicon softeners. Next slide. What is textile finishing? Textile finishing is the term for a whole range of mechanical and chemical processes that are used on textile after their manufacturing to provide desired qualities and make them more marketable. Next slide, please. Here is some textile finishing processes, figures from our industry. Next slide, please. Here is also some figures. Next slide, please. Innovation of softening. In textile manufacturing, finishing refers to the process that converts the woven or knitted cloth into a usable fabric or any material, and more especially to any of the process performed after dyeing the yarn or fabric to improve the look, performance, feels of the textile or clothing. Some finishing techniques such as bleaching and dyeing are applied to yarn before it is woven, while others are applied to the grey cloths directly after it is woven or knitted. Some finishes such as filling have been in use with hand weaving for centuries. Others such as mercerizing are byproduct of the Industrial Revolution. Next slide, please. Here is the picture of the innovation of our innovation technologies in Special finishes for natural fibers and fabrics. Special finishes for natural fibers. Biopolishing removes the protruding fibers of a fabric through the action of an enzyme. Enzymes such as the cellulose for cotton selectively remove protruding fiber. Those enzymes can be detected by an increasing the temperature. Mercerization makes woven cotton fabric stronger, lustrous to have better affinity to dyes, and abrasions will be reduced. Next slide. Special finishes for synthetic fiber and fabric. Here are heat-seating, anti-peeling finishes, anti-static finishes, and non-slip finishes. Next slide, please. Garments finishes. Garments finishes including with frictional finishes, rubbery touch, stone wash, non-stick Teflon spray, feather touch, and ultra soft touch. Next slide, please. Here is some chemical finishes, some elements of finishes on garments, which we used as a chemical finish, biological finish, protective finish, and mechanical finish, and also a thermomechanical finishes. Next slide, please. Here is a wrinkle chemical finishes, and also here some wrinkle-free finishes. Here is a pad dry cure method we seen in the picture, which is here we use as a cross linkage agent 40 to 120 and manganese chloride 10 to 25 and softeners combination with 40 and whitening agent 1 and acetic acid. pH is controlled through 4 to 4.5 over. Normally, cross-linking agents are applied by pad dye cure method. And here is a softening method. The introduction of novel polysiloxane softeners in both micro and macro emulsion form has been the most significant change in the softener field. Cotton has an ultra soft
Maria,
handle.
sorry to interrupt, but you have just 1 minute left. You can jump to the conclusion.
Okay. Here is some water resistance breathable finish, water stain and oil repellent finish. And next slide, please. Biological finishes, biopolishing finishes, leather finishes, rubbery touch, micro encapsulations finishes, fragrance finishes. Next slide, please. Protective finishes, insect finishes, antimicrobial finishes, skincare active ingredients of our fabrics. Next slide. Next slide, please. Mechanical finishes, rising, pitch, sweding, and laser and foiling finishes. Next slide, please. Here is a thermomechanical of finishes, which was combined with two methods, plasma method and one is clandering method. Next slide, please. Latest innovation of finishing in Sexton nanotechnology and low or ultra low formaldehyde easy caring finishes are described here. Next slide, please. In the last slide, conclusion slide. Hello? Next slide, please. Can you hear me? Can you hear me? Can you hear me? Can you hear me?
Yes, we can hear you. I think some participants got disconnected.
Okay.
If there is problem in internet connectivity, can I know that their presentation is completed?
I think there was only one slide to go.
Yes.
Okay, no problem.
That's the conclusion slide.
Acha. नहीं, एक conclusion की slide है. Pradeep sir, are you able to listen me?
Yes, I can hear you. I am connected. No issues.
Because now I have joined with my mobile phone, and can I ask her to complete the last slide?
Yeah. Go ahead, please.
Maria, please
Sir,
you
from our
go to
side,
your
information
last
is lost.
slide,
We
conclusion
cannot
slide.
present the screen right now.
Yes, sir.
Acha. Okay,
So,
then
sir,
we
you can
will
just
wait. I don't
start
have
with
any
the Q&A
problem.
session.
Okay, I can go first this time for questions.
Yes, sir.
So here you asked me. You talked about several type of specialty finish, and one point that you mentioned was about formaldehyde. So,
Yes,
in
sir.
which type of finish you have formaldehyde evolved from the finish? Like, what would be the type of finish, and what would be the compound in this case?
Sir, it's a biopolishing finish and antimicrobial finishes where we use formaldehyde.
Okay, thank
Acha, Maria, what are different mechanical type of finishing treatments that can be given, and please tell their applications. Like raising, if we are raising, for what
Yes, sir.
purpose such fabric can be used?
Sir, in raising fabric, raising finishing soft and spiral handle of fabric, which we can use as a fabric moved as a central drum mounted with a series in moved over a central drum, which is an application, a series of peel and counter peel roller that moves in a such way of fibers is lifted and controlled manner, where we use in soft fabric.
Acha.
Soft and lifting fabric, sir.
Okay, over.
Thank you, sir.
Yeah. Okay.
Okay, sir, we'll just wait for 5 minutes. There is some technical issue here.
Yeah, no problem. I'm ready to wait. I'm there.
Okay, sir. Thank you, sir. Thank you, sir. So, Nikhil, are you ready? Okay, we'll start.
Yes, sir.
2219. PPT 2219, you can start your presentation. Are you sharing from your end or we have to share?
Yes, I am sharing. It is visible, sir?
No, it is not. You have to share, like you have to press share on the presentation.
Take 1 second, sir. That is visible, sir?
Yes, it is visible now.
It is audible.
Yes, audible, sir?
Yes, it is visible and you are audible.
Okay, sir. Good afternoon, all of you, sir. Myself, Nikhil Yogesh Upadhyay. I am studying in third year textile chemistry in DKTE Textile and Engineering Institute. First, we go with the introduction part. of softening finishes. In the purchasing of new fabric and garment, we have to first see the color, and then we go for a when we uh, when we feel color is very excellent, then we go for a hand feel of the fabric. When the hand feel is very good, then we, after liking the fabric, then we uh, purchase the fabric. Softeners for finishing. What is the softeners? Then softeners are the chemical auxiliary which is applied to the textile material in order to improve the textile material, that is increase the flexibility, durability, smoothness, handling. And it is nothing but softening is nothing but to reduce the coefficient of friction between the fiber to yarn to yarn. It is, that is softener to for finishing. Reason for softening, why we use softening in chemical processing or mechanical processing. We have to in processing, that is become a harsh fill because of chemical and mechanical processes. Because of that, we feel some harsh fill onto the surface of the fabric. Because of that, we have to soften the surface by using auxiliaries and chemicals. In further slide, there are a classification of softening methods, that is mechanical finish. In mechanical finishing, resin, decadizing, calendering, these are the mechanical finishes whether we can give the surface properties with increasing the softness. These are the chemical finishing treatments, softeners, that is cationic softener, anionic softener, non-anionic softener, amphoteric softeners, reactive softener, silicon softeners. These are the drawbacks of conventional softeners. Some softeners contains amine, cause yellowing problem. Because of that, we get shade variation. Because of that, light fastness will affect. Residual chlorine in bath, presence of residual chlorine in bath. Because of that, affects soil removal impurities. Softeners such as anionic and cationic softeners have limited durability, laundering, and dry cleaning process. Non-anionic softeners usually have negative effect on wet fastness also. Reactive softeners high cost. Silicon softeners create water repellency. Because of that, making them unsuitable when absorbency are required, and also it is expensive. Next importance will give Vikas Wali.
Good afternoon, sir. As discussed earlier, drawbacks of the conventional softeners. So we are creating some innovation in softeners, like by adding some chemical and innovating some conventional softeners. By adding some functional groups, we are developing new softeners like silicon. This is the conventional silicon softeners are silicon oil based. By adding some functional group, we are developing new softener, and the classification are given as non-reactive, reactive, and organofunctional softeners. Next, first we will see the how the non-reactive silicon softeners are working. These are a dimethyl silicon oil, also known as poly dimethyl siloxane or PDMS, which contain mainly silicon oil. This is the mechanism how the silicon oil are the non-reactive silicon softeners are working. These are non-reactive. So they only attach the fabric with the van der Waals process. Here you see that. Then reactive softeners are the reactive group containing silicon softeners. This is the most common type of silicon material which combines with variety of single combustion by the chemical reaction we discussed here, like a fabric containing hydroxyl or carboxyl, which is attached with reactive group. And then please next slide. Then third is the organofunctional. Organofunctional are a multifunctional softeners. It contains mostly a part of fatty acids, amines, condensate, and multifunctional softeners. Here we discussed that the multifunctional softeners react with the fabric by a functional group. So it provides a softness to the fabric. Next. These are the advantage of some silicon softeners. Silicon softeners these are ecologically inert and environment friendly, do not affect the aerobic and anaerobic bacteria. It does not inhibit the biological process. and then the amino functional group polysiloxane softeners improve the fabric quality rather than hand. Also, it is we also called as some special finish. And if we apply it cotton fabric, then it increase the durability, stretch, and recovery, and other some properties of the fabric also. Next.
Sorry for interruption. Your PPT is not changing. The slides are you are on first slide only.
Oh, sorry. So I think we are in a.
I think there is a problem. Can you share again?
Should I share from my end?
Yes.
With second slide. No one is telling that that is second slide.
Okay, we are in now. Oh, please next. Okay.
Previous one.
Previous one. Okay. Here, these are the advantage of some silicon softeners. We are discussed that is ecological, inert, and environment friendly. They does not affect the biological process. And if amino functional polysiloxane softeners, if we add it to silicon softener, then it improves fabric quality. And if we apply it to the neat cotton knit material, it also improves the fabric durability, stretch, and recovery. Please next slide. After silicon softeners, we are developing some environment-friendly wax and their emulsion softeners. Mostly used are carnauba wax. This is also known as Brazilian wax, which are obtained from palm leaves. It is mostly found in Brazil, so we are called as a Brazilian wax. It is odorless, yellow to dark brown greenish solid. It is mostly contain of mixture of esters of fatty acids and fatty alcohols and also hydrocarbons. They are applied in the form of emulsion by forming a emulsion by melting it and emulsify. Next is a bee wax. We know generally bee is honey, and the remaining is material is wax, which is a British brownish compound. It contains mostly fatty esters and fatty alcohols. The most major component which gives the softness is trichonithyl palmitate, which has an ester.
Nikhil,
Next
sorry
slide,
to
please.
interrupt, but if you have given, I have given you 30 seconds extra also, but now only 1 minute is left.
Oh.
So please jump to the conclusion.
Please next slide, sir.
Please next slide.
Okay. The most commonly used in is the polyethylene emulsion softeners, which is the mostly used in industry, which is polyethylene, and the molecular weight is up to 10,000, 1,000 to 3,000. Under specific condition, proper oxidation if we made, then it improves the hydroxyl and carboxyl compound, and which gives a special effect like hydrophilicity and also some sewability and other properties. Please next. Please, this is the application method how we apply. This is pad dry cure, where we use pad two dip two nip method, then drying under 60 to drying under 60 to 80 degrees Celsius, and then cure at 180 degrees Celsius. Please next.
Nikhil,
Okay,
sorry to interrupt, but your time is up.
Okay.
Let's move on to our Q&A session.
Okay.
Okay, Mr. Nikhil.
Yes, sir.
Please tell me what are the chemicals used for giving protective type of coating and their applications. Maybe one or two.
Protective clothing, sir. For which protective, sir? For which application protective?
Any one or two you can tell me.
Functional finishes also used. Functional finishes, that is mosquito repellent finish. That is one. Yes, sir.
Right, you are. Go ahead.
Yes, sir. Mosquito repellent finish, that is from mosquitoes. Because of that, we protect from the mosquitoes. And one more, that is a water repellent and waterproof finish. That is widely used in tarpaulin or any other application is one more example, self-cleaning textile. Because of that, we apply any other stain, or that is self cleaned automatically.
Okay,
Okay, sir.
okay, thank you. Your friend now.
Yes, sir.
Vikas.
You said that this is silicon is non-reactive type of finish.
Yes, sir.
Means it will not react with the fiber material. Then how it will stick up to the surface? Tell me the mechanism.
Sir, on mechanism, it contain mostly silicon and which with some functional group like oxygen and methane or methyl groups. The oxygen forms a hydrogen or van der Waals force with the fabric, and the surface is a methyl group which act as a lubrication and which soften the material.
Right. Okay. Kapadia sir.
Thank you. Thanks for a good presentation. I just have one question on the process part, where you said it goes through pad, then drying, and then curing.
Yes,
Yes,
sir.
sir.
Yes, sir.
So in curing step, what exactly happens here?
When we use, sir, siloxane or silicon type of softeners, in that softeners are in reactive softener or non-reactive softener, and that is surface in curing, that is temperature near about 170 as per the quality, 170 to near about 210. That is that's a high temperature we have to use in a curing chamber. In that surface is uh, in the surface, we have to apply thin layer, and that film is get uh, fixed by the chemical, that is softeners, that we have to use in earlier slides. Bridge between fiber and main mechanism is that in softener, that is we reduce the coefficient of friction, means we reduce the slippage. That's it, sir.
Okay, sure. Thank you.
Thank you so much, Nikhil. We'll head towards our next participant, which is double two double two. PPT double two double two. You can start the presentation.
Should we present from our end, or you are going to present?
I will present from my side.
Sure, sure. Go ahead.
Can you present from your side?
Yeah, we can. I can present.
Good afternoon, respected teachers, the organizers, and dear participants. Thank you for giving me the opportunity for presenting my paper on advancements in oil and lubricants in textile industry. I am Sujit Kumar Behera from Odisha University of Technology and Research, Bhubaneswar. Next slide. And the oil and lubricants used in textile industry performs various purposes. The major purposes are described herein, like reducing frictions, cooling, finishing of fibers, yarn, and fabrics, and in machine cam box, where modern machines are used, a huge amount of oil is required for lubricating purpose. Next slide, please. The oils can be categorized into two forms, like organic oils and synthetic oils. Mostly, organic oils are used in textile industry. For example, ester oils, which are derived from crude. Next slide, please. The synthetic oils have major three components that they are chemically formed with the help of molecular structures proper molecular structures and molecular weights. The main components of synthetic oils are polyalpha olefins, synthetic esters, and polyalkylene glycols. In 2014, around 95% of the market share is around synthetic oils that is used in the textile industry, out of which polyalpha olefins is the major useful oils for the textile industry, which accounts 44%, followed by ester oils, that is 30%, and then polyalkylene glycols, which is around 16%. Next slide, please. Polyalpha olefins oils are saturated olefin polymers, and this saturation will give us various characteristics like high thermal oxidation stability, high viscosity index, and low volatility. For these properties, these polyalpha olefins oils are the major demand in textile industry. Next slide, please. Olefins are like dimer, trimer, and tetramer. These are the branched chain alkene groups which will help the oils to remain in the amorphous forms rather than crystalline forms, which will increase the viscosity of the oils. Next slide, please. Ester-based oils are having various derived from various families and have severe environmental applications, and they are custom tailored. That is, they are manufactured according to the needs and requirements. These are composed mainly of branched hydrocarbons, and there is a presence of oxygens in their branch, which will form the polarity of the ester oils. This polarity gives specific characteristics like low volatility, high flash point, thermal stability, high solvency, and biodegradability. Next slide, please. These are the various kinds of families of ester oils like diester, polyesters, trimethylate, and pyromethylate. These are the various kinds of ester oils. Next slide, please. Then polyalkylene glycols. These are the produced from ethylene oxides and propylene oxides in different ratios according to the research paper Rutkin. This ratio will determine the application of polyethylene glycol oils in different forms. They have high fire resistance and high loading capacity, which will
Sujit, I'm sorry to interrupt, but you have just 1 minute left.
Okay.
You can jump to the conclusion if you want.
Okay, I will lead to the advancements in oil and lubricants. Next slide, please. Lubricants. These are the various. What are the advancements in oil and lubricants? Like we can use additives and antioxidants for the oil and lubricants for the increase in for the reduction of oxidation process in these oil and lubricants. After some times, they will oxidize and form higher molecular weight polymers. Next slide. Next slide, please. That is virgin lubricants. Virgin advancement number 1 is virgin lubricants. They are some of the lubricants that are used with the help of additives. Antioxidants, this improves the thermal stability of the lubricants. Next. Next slide, please. Advancement number 4 is the Mainland and Novozymes. These are the two companies. They will form a greener synthetics pathway towards the enzymatic interesterification process of. They form a enzymatic process of interesterification of oil and lubricants, which will interchange the saturated and unsaturated fatty acids. This is the prize given by the US Environmental Protection Agency. For these groups, they have developed some interesterification process for the oil and lubricant formation. Next slide. In 2015, Nobel Prize was given to the researchers for their invention of metathesis process, which will lead to green chemistry.
I'm sorry to
Yes, sir.
interrupt again, but your time is up.
It is the final. It is final. This is the final slide. Metathesis reaction, it will increase the, it will lead to green chemistry with the help of catalyst like ruthenium alkydes. This process can be incorporated for the production of oil and lubricants also. And these are the references in the next slide. Thank you for giving me the paper presentation.
Okay, Mr. Sujit, it was a very much informative presentation.
Thank you, sir.
Can you tell me what is viscosity index?
Viscosity index is the ratio between the resistance to flow of liquids to the resistance to flow of substrate.
Acha. So if suppose viscosity index of the oil is better or higher, what property it will have?
If viscosity is higher, then it will reduce the lubricating property and it will give us high temperature stability also. And after some times at high temperature applications, it will form higher molecular weight, which will reduce the lubricating property of the oil.
Okay. What is the specific property of polyglycols, which are used as a synthetic lubricant? One specialty is there.
These are high fire resistance and give better molecular stability.
Okay. It is over to you, Pradeep sir.
Thank you. Thank you, Sujit. Was a very interesting presentation. Just have one question. So when you say about polyglycol versus esters versus mineral oil, what would be the difference in key properties as well as the cost? Thank you.
About the properties, they have various advantages and disadvantages, but the costing part I have not touched much. The properties that polyethylene glycols can have high fire resistance property and molecular stability, whereas the ester oils have poor oxidative property and thermal stability property at high temperature. I can lead you a slide number 5 that will demonstrate these properties, if possible. Bhargav? Bhavya? Sir? Can you show the slide number, please, for the
slide
properties?
Okay.
Slide
Okay.
number.
Which slide?
Slide number 10.
10. Properties.
Yes, and here we have compared the various properties of synthetic and mineral oils and their characteristics and what are the good, very good and excellent properties they exhibit. The oxidative property and the mineral properties and the thermal stability property of polyester ester is quite average. This is the major regions that need to be advancement, for which we are adding additives, antioxidants, and other advancements we are looking for. Thank you.
Thank you.
Thank you. Thank you, sir.
Thank you, Sujit. We'll head to our next participant, PPT 2227. 2227, you can start your presentation.
Should we share a screen from our side or you are sharing from your end?
Yes, sir, you said.
You can start your presentation.
Yes, sir, thank you. My name is Prerna Suresh. I'm audible.
Yes, you're audible.
Hello everyone. Good afternoon. My name is Prerna Suresh Upre and my partner name is Rutuja Mahadev Jadhav. Today I am presenting the presentation about the oils, lubricants for testing and test standards. First, we see the content of this presentation. Next slide.
Sorry to interrupt you.
On mic of one participant only so that there will be no mic.
Now, Prerna, you can continue.
Next slide. sir. Hello. Hello, I am audible.
Shivtej, she is saying that next slide is to be displayed.
Thank you. Now we see the content of this presentation. First one is the introduction. Next is definition. Next is testing of oils and standards. And next is standards of oils and lubricants. Next slide, please.
Rutuja, you are not audible right now. Rutuja, you are not audible.
Rutuja, unmute yourself.
If there is some issue from Rutuja's side, then Prerna, you should continue.
Yeah. Okay. Now we are see the introduction. Oils and lubricants. Oils is the general terms used to clear oils, liquid lubricants, whether they are minerals oils, natural oils, and synthetic oils. Next, testing of oils and lubricants. The most important thing in the testing is to the match the test to object to the testing, and standards is the lubricant specification are internal documents that contain the technical standards. Next slide, please. Now we see the definition of the oils and lubricants. Oils and lubricants is the class of the reduce the friction between the surfaces of machines and the material which is the used this way is called a lubricant. Lubricants are usually liquid, semi-liquid, but may be solid and gaseous or any combination of solids, liquids, and gases. Next slide, please. Rutuja is not there. Hello.
Yes, you can continue.
Rutuja.
Prerna, it seems that there is some problem from Rutuja's side. Can you continue?
Okay, sir, I will. Next is the testing of oils and lubricants. The objective of the testing of lubricants or for anything else may be done for the number of different reasons, and the following are some example of the reason. First, we need to find out if it will work well in the particular piece of the equipment. Next one is the to find out if it will be survive to particular conditions, such as the heat or the humidity. Next one is the to ensure that it is safe to use and not toxic or healthy formable. Next one is the to find out if it is the some type of the oils as per previous shipment. Next slide, please. This is a type of the testing of oils and lubricants. First one is the functional test. These are the designed to the show how to lubricants perform its function or the lubricant. Uh, in this picture, this is there. Next slide, please. Next type of test is the chemical test. In this test, this is the involve measuring some chemical property of the lubricant, such as the acidity or the concentration of the some chemical substance which present in it, such as the calcium or naphthalene. Next slide, please. Third type of the test is the physical test. Physical property may be measured either because they are themselves important, as with the viscosity, or because they are give information about the some other except, as when the color indication is safe of used to lubricant. Next slide, please. Next one is the standards of oils and lubricants. Standards are importance for all lubricants. They help to helps to person to buy the which type of oil, and such a document of a specification, although it may be called the data sheet or the standard. Uh, Standards are usually applied. Standards are usually applied of a national or international level, and some of the important standards making organizations are in the following. Some are the standards are there. Next slide, please. It is the conclusion of oils and lubricants. Lubricants oil, sometimes simply called the lubricants and tube, is a class of oils used to reduce the friction, heat, and the wear between the mechanical components. They are in a contact with each other. Lubricant oil is used to mention vehicles where it is known specially as motor oil and the transmission fluid. Next slide, please.
Okay.
Thank you for listening my presentation.
Prerna, will you tell me what are the types of tests required for assessing the lubricants?
So the first one is the functional test, next one is the chemical test, and third one is the physical test.
Okay. Can you give one example of physical testing? Any one physical test. Tell me the name.
No, sir, no.
Okay, give me name of one chemical test. You have read it. तू ते वाचलेस.
Yes, sir.
Okay, what are the benefits of testing the lubricants by physical test, chemical test, and functional test?
Sir, a tester helps to percent which type of lubricant we are used to machine.
Okay. I think Rutuja cannot answer any question. Rutuja, unmute yourself. We will check whether the still problem persists on her side. Okay, leave it, Rutuja. It seems that there is still problem. Kapadia, sir.
Thank you, Prerna and Rutuja, for a wonderful presentation. I have a question on performance test. So, if I have to use this particular oil in transmission versus gear versus engine, for example, so what type of performance test I should do? So, because it won't be feasible to run all the samples on a real, say, motor or engine of a vehicle, for example. So, what else can be done instead of using it on a real engine?
Mm-hmm. No, no idea.
All right, thank you.
Thank you, sir.
This is last call for PPT 2233. If you are there, like we are waiting for you. This is last call for you.
Shutej,
Yes, sir.
you have contacted him, no? 2233.
Yes, sir. Yes, sir. We have
And
tried.
there is no any response from him.
Yes, sir.
Then we'll stop his presentation, or we'll not take his presentation.
Yes, sir. Sure.
And this, I think this
Okay, sir.
this will be the last, no? This is the last one.
Yes, sir. It was the last one.
Okay. Then let the others to leave.
Yeah, okay, sir. Thank you so much for your participation and cooperation. Judges, thank you so much for your precious time as well. And you can leave this meeting and we'll let you know the result by 5 o'clock and we'll share a link again in our WhatsApp group.
Okay, thank you, sir.
Okay. You all can leave now. Thank you.
you.